All right. Hello, everybody, and welcome to the stream. Hope everybody's doing well tonight. We're getting a bit of an early start tonight. Hoping to knock some good stuff out tonight. Vulkan, thank you for the follow. Welcome to the stream. Hands me a coffee. Appreciate that. Probably going to need them tonight for sure. But yeah, we have lots of stuff on the roster tonight. I have gone ahead and done some stuff offline as well, so I will quickly discuss what some of those things are, and then we will move on to actually getting the rest of this stuff implemented. Before I jump into that, I do want to take a quick second and just thank the supporters of the channel, starting with the partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Gaby Bashir and Gerbolis Inc. I would also like to thank all the other supporters on the channel. They are listed here. They are the other tiers of support on Patreon, YouTube memberships, as well as Twitch subs. So thank you all very much for your support. I greatly appreciate it. I would also like to thank all of the viewers of the stream, either here or on YouTube. So we simulcast between Twitch and YouTube. So I do monitor both streams. I have them both here up in the monitor, so I can see chats on both. And so obviously without you guys, this project would not exist. So thank you all for being here. All right. So kind of where we left off last time is we were in the middle of kind of a big refactor effort having to do with our descriptors, our descriptor sets, our descriptor bindings to allow arrayed types. And we got pretty well into that. But I did, just to kind of keep things moving, I did a little bit of dev off camera as well, just because if I waited to do all the dev on camera, we'd be here forever, right? So we'll quickly talk about what some of those changes are, but the highlights of that are mostly over here. So I've been keeping most of the changes I've been doing in the changelog. And so basically this should be samplers and uniforms. So we changed the way that samplers and uniforms work on the front end and the back end to allow arrayed uniforms. So when I talk about arrayed uniforms, I mean like an array of matrices or sampler 2Ds or something like that, where we can describe a array like this, both in the shader config as well as the shader itself. So if I go to, let's see, what's a good example? PBR is probably a good example. So if I open up the shader config file for that, this looks a little bit different now. And I think we touched on a lot of this stuff last time. But we basically have this this uniform description here, where we have a array of sampler 2Ds, and that array is of size 5, right? And it's on an instance scope, as are the shadow textures and the cube texture. And so these two are essentially array typed, and then the sampler cube guy down here is just a single one, right? We could also do this, and it would essentially be the same thing as far as the config is concerned, right? And so that's the support that we're building in for that stuff. And then also we are building in, let me just undo this. We are also building in support for, let me open up this guy, support for regular uniforms to have that as well, not just samplers, right? So if we have an array of matrix 4s right here, we have this ability for any type of uniform, right? And so the goal behind that is obviously to be able to support these types, configure them, and then have all the pipelines and stuff set up in the engine automatically to handle all that stuff, so that when we write a shader and write sort of the metadata, which is what this file is, we don't have to go back and edit the program to actually support that stuff. So that is kind of what we are working on, right? All right. Kofi. Yeah, no Kofi implementation to tip you. I don't, what do you mean? Like, it should, I haven't actually tested that, so I don't actually even know if it works. But I don't know, I don't think it's integrated with Twitch at the moment. So I'm not sure about that. But yeah, that is something I've been meaning to test. I just haven't tested it yet, right? So, Mootvari5, thank you so much for the follow and welcome. Glad to have you here. The other thing that I wanted to quickly bring up is the YouTube channel is really close to 12,000 subscribers. So I'm kind of hoping that that rolls over to 12,000 by the end of the year. That's my goal. And it's only that many away, right? Was that 27 away? So, yeah, that would be really neat. All right. Anyway, what are you doing, browser window? All right. So, to go back to our changelog for a second, just to wrap up what you're talking about here. We changed this. We already kind of talked about the shader now not only supports the specification of the sampler type, right? Before we just had samp. Now we say sampler 2D, sampler cube, sampler 2D array, etc. But it now requires that, right? It is for backwards compatibility. If you just say samp like we did in our old ones, it sort of defaults to sampler 2D. All right, let's see. I think we also added an argument to our uniform setting functions to allow for setting of indices of arrayed data. So we'll kind of get into those a little bit. I changed a little bit of the naming from uniform index to uniform location, just because it was kind of inconsistent, and I went with uniform location on that. I moved the shader file parsing from the back end because it was done in the Vulkan back end. Now it's done on the front end. And that is in preparation to support include logic. And I don't want to do that by different APIs like DirectX or OpenGL or Metal. I don't want to have each one of those handle it. I want to sort of handle it on the front end and just pass all the included shader code to the back end. So we're going to be implementing that in the front end pretty soon. And then we also implemented some changes to allow not having global or not having instance UBOs and or samplers, right? We kind of had half support for that before, but the UBOs were always kind of required, right? And now we can actually have shaders that don't have those things. So I'm still in the process of testing those changes. So there may be some things to fix there. We've also removed the Fong material type and any shaders and anything that was that referencing that. Everything's PBR now. I also removed all traces of the defunct UI material type because we don't use that anymore. We haven't in a while. Let's see. I think we moved all the uniform sampler count logic to the front end to support queries on that, so we can query the data and not have to reach into the back end for that. Let's see. Okay, I think that is mostly what we've kind of done since the last one, right? So those are kind of the things that we're gonna look into. So with that in mind, I'm gonna go to the render backend and just talk about a couple of quick things. So whenever we apply an instance, if that instance is, let me see, where is it? Oh, this is the apply. We want the set. Let's see. Apply instance. Yeah, it's just uniform. So it's technically not just, yeah, uniform set. Here we go. So uniform set now takes an array index. And this array index can be 1 if it's not arrayed, right? But it always takes an array index. And the reason for that is because when we are either doing push constants or we are copying into our mapped block of memory, we now take the uniform offset plus the size times array index into account. So that allows us to set a particular index of that array in memory at a time, right? And so it's a small change, but it was one that greatly improves the flexibility of our API. So that is that. And most of the other stuff I've been working on has dealt around the shadow map pass and actually utilizing this stuff, right? So that's probably where we're going to spend most of our time tonight. So, all right. In fact, I'm going to get rid of this extra buffer here, and we can continue on that. So why is the array index 1 if there is no array? It's basically saying, 1 times whatever it is, right? Technically, you could pass... Oh, wait a minute. You know what? That might wind up actually being an issue. Well, no, it won't be an issue. So an array size of 1 is basically just saying the same thing as if we don't have an array at all. Array size of 0 doesn't really make sense, right? Because then you'd have nothing. So we say array index could be 0 based, but array size would not be. So I may have misspoke there. I'm not 100% sure. But array index would be your offset into that array versus array size. So yeah, if we don't have an array, that would be 0, not 1. I think I misspoke there. All right. So there are a couple things that we have to do to this shadow map pass to actually get it to work that way that we want, actually, and I need my split back. So in testbed main, where we set all of this stuff up, where we configure the render graph, we're going to have to modify this slightly. And maybe it makes sense to modify it from here first and then implement this. So the way that we have it right now is we have our individual passes sort of defined, right? We have our global sources, our skybox pass, and then our shadow map passes. And we have 1 per cascade right now. And we're basically just creating a pass per cascade, which is kind of poopy, right? And we said that was going to be a temporary thing just to kind of get it to work while we were testing stuff, and then we would come back and actually implement this the right way. So what we're going to do is we are going to essentially set up this pass as a single pass, right? A single render graph pass. And then implement the multiple passes within that. And that'll allow us to sort of take away this concern from the application and off-source that onto the pass to actually implement those multiple passes, right? And so basically we have 1 pass per cascade. And then down here in our scene pass, we add our sinks 1 per pass. And then we link up our sources to those sinks 1 per pass here. And so what I'm actually thinking of doing is having a sink that supports an array, which we may have to write some logic that does that. And then we just pass, we have 1 sink and 1 source, and then this one will just grab what it needs based off of the index, right? So when we go to do the scene pass, depending on which shadow map we're using, it should pull from this guy. This is the way that I'm thinking about that, right? Shadow map calculations are done on the CPU currently. By calculations, you mean like viewports and stuff like that? Matrices? Yes. That's done on the CPU. The shadow maps themselves obviously are rendered on the GPU, but yeah, we do most of the calculations sort of the old school way. Axorus, hope you had a good holiday season. Thank you. I appreciate that. Hope you did as well. Welcome. Like creating the bitmap images. Yeah, so the bitmap images are... The bitmap images are executed from the CPU, but basically they're done on the GPU. But I'm not using compute for any of that stuff, if that's what you're wondering. We're basically just using blitting, right? Which I think that's done on the GPU. I think. It might be done on the CPU. I'm not 100% sure, to be honest with you. Either way, it's pretty quick. All right, so I guess probably the first thing we need to think about with this is how we go from having multiple passes to a single pass. Because we have different sets of resources for each one of these. And I suppose maybe the first way to do this, we have this depth buffer here, which is technically the output, right? So maybe the lowest path to entry here would be just add more sources, right? And then hook those sources up here. And then we can worry about the array stuff later. Maybe that's the way I'll do it. So instead of depth buffer, I'm going to name this shadow map 0. No, you know what? That's going to be confusing. Let's call it depth buffer 0. All right. The source origin is going to be self, meaning that the pass owns it. The render target type is depth stencil. That can remain the same, so we should be able to just duplicate this a couple times and then do that, right? And that should give us everything that we need, I think. All right. So we do that. We get rid of this array. Or we get rid of the concept of the array there. Impter56, thank you for the follow. I appreciate that. Welcome. We also have this shadow map passes, which needs to become a single version of that. Mr. Swez, thank you for the follow. I appreciate that. Welcome. How are you doing tonight? So let's see. We actually don't need this name buffer stuff anymore. So we can just actually put, let's do this. Let's do this, and we'll say name buffer equals shadow map pass. Right, and it's going to be a single pass, so we're not going to have this business down here of multiples anymore. We can get rid of, whoops, we can get rid of this guy. We can rename this to shadow map pass name. I don't know why it didn't do this one. Okay. Instead of shadow map passes, we are going to go back to having a singular pass. Okay. That comment is no longer, oops, actually I don't want to delete the whole thing. Let's just do that. So we have the shadow map pass. We're still going to use 2K maps. I think that's fine. So, all right, so we've added the sources to that. The sinks can be the same. Shadow map pass, and then just the depth buffers need to change here at the end. So 0, 1, 2, and 3. Okay, so that should hook up. Should be good on that. We may actually have to, when we set the sync linkage, we may have to do some work there. I'm not 100% sure. But I think that's all going to be work again in the shadow map pass itself. So that should be fine. So this is half of it. That's basically our configuration of the pass and how it relates to the render graph itself. The other half of this is going to be how we actually prepare the frame and call that, right? Let's see. let me catch up here. Hi, what's your IDE? This is NeoVim with a series of plugins. I actually have my configuration is detailed here. I'll drop that in chat. So there's a link to my detailed NeoVim configuration there. Vulkan stuff sounds cool. Yeah, Vulkan is it has its moments for sure. And coolness and uncoolness for sure. I was actually wondering why you would add that more code into that. Wait, I was actually wondering why you would add that more code in a for loop. I assume you mean the for loop that was here. Yeah, it was kind of a hack that we did just to kind of get this up and running, right? And we're kind of doing away with the hack now. Can you do basic simulations with this engine now? Depends on what you mean by simulation, right? So we do have a rendering pipeline set up with the ability to load in static meshes and a height map terrain. We have PBR, we have lighting, we have shadow maps, which is actually what we're kind of messing with now. But we don't have physics yet. So physics isn't required to make all games. So in fact, the first game we make with this engine probably isn't going to have physics. But yeah, I mean, you could probably make a game with it as it stands right now. We have the ability to load and unload scenes and things like that. So yeah, I mean, it's still pretty early days, but I am going to be making multiple games with this engine as we continue, just to kind of act as a litmus test for the engine itself, right? The for loop I got rid of. Yep. Okay. Cool. So I hope that answers your question, Mavi. And first time chat, by the way. Welcome to the stream. Glad to have you here. Okay, so that is that's that portion of it, and I'm thinking we should probably set up the prepare frame aspect of it as well, so that way we can get all of the work outside of it done and kind of know what it needs to look like data-wise, and then make our changes within the pass itself. So we need prepare frame, and here is where we actually start setting up our shadow pass, right? So I think the splits can stay like it is. Shadow camera lookouts, kind of go ahead and set up that array. And then we only do the shadow map pass if there is a directional light. And then here is where we loop for the cascade count. So the way that this works currently is it basically sets up an entire data structure for each loop of this, each cascade, which is not necessarily what we want to do, although a lot of it is going to wind up staying just as it is as well. Let's see. So the main things that we need to know per cascade, right? We don't actually have to execute this in a loop like this anymore, but the main things we need to know is our cascade index obviously is going to be 1. What our indices, or I'm sorry, not our indices, what our matrices are for each pass. We need to fill out the extended data for that, which actually cascade index is now not in here as well. So I think this was because that's under cascades. Cascade index, right? So we have this new, I guess I should probably show this too. So in our extended pass data, we now have this shadow map cascade data with data for each cascade. And within that, we have a projection matrix, view matrix, what the split depth is, and then what the cascade index is. And I'm thinking this is all we're going to need to know. But in order to generate this stuff, we are going to have to calculate what all of these things should be. So we're basically changing from setting this up for multiple passes to setting it up for a single pass. Yeah, so you noticed this little guy, right? This is the only time I use C++. right there as an iterator. And you'll notice that a lot of my other iterations, I do ++i, but I specifically did C++ here for that. Because that's the only time I use C++. Okay, so Cascade, this is not relevant anymore. So we should probably move, let's move this, oops, wrong key. Let's move this up here, and we're going to call this pass. And we're just going to change it to that. And then we want to, actually this can be moved up as well. All right, so pass data, do execute. We want to execute that render pass. Obtain the light direction. Okay, so we don't need to do that each time. So this could actually be moved up. And these couple of lines here can also be moved up. So we can put these guys here. And this is going to be just pass. Okay, so we do that once. We go ahead and set the cascade index. That's fine. Camera view projection. Do all this calculation. This stuff has to be done per pass. So that's fine. All of this is fine. Okay, shadow camera lookouts. So, okay, this is what needs to change a little bit. So instead of cascade, let's see, cascade, shadow map cascade data. That's what I want. Let's do this. It's the address of ext data cascades sub C. And then I can just say cascade index equals C and do away with that. That's a little cleaner. All right, let's see. So a little further down here, we're not going to be setting the view and projection matrix and the pass data anymore. By default, pass data, like the standard pass data, has view and projection in it, but we're not going to be using that because we need multiples of them. So instead, what we're going to do is we're going to set the view, equal to shadow camera lookouts C, and then projection. We'll set that on the actual cascade itself. And we're going to have adds here in a second. So I think the split depth is actually going to be cascade data as well. So we'll store that. Okay. This is all about the visualization stuff for the pass. So I think a lot of this can go, but I'm not going to get rid of it yet. We'll clean that up afterwards. That's why I put hack tags around it. Because once we have this working, we don't really need these visualizations anymore, and we should really get rid of this stuff. So that's what a lot of that is, just visualizing the frustums in 3D space. So I'm not going to keep a lot of that stuff. Let's see. Most coders are kind of confused by what you mean. Does ++x or x++ mean? It's just different ways to iterate, right? Post or pre-iteration, depending on what you're doing. In a for loop, it actually makes no difference whatsoever. Not anymore, anyway. And yeah, I would say that most programmers, well, I would say that most C programmers know what the difference is. I can't speak for a lot of others, but keep it in for debug reasons, yeah. Let's see. So we have some of this stuff, like I'm not sure that we need this shadow camera look at stuff anymore. We have ads. So for those of you who are new here, either to Twitch or to the YouTube side, once every 30 minutes, we get 90 seconds of ads, or up to 90 seconds of ads on the Twitch side. So that can vary depending on locale, platform, things like that. And so I like to pause the stream whenever that comes up so that nobody misses any content, because nothing is worse in a programming stream than having ads come up when there's code on the screen that's being explained, right? That kind of sucks. So yeah, that's why we do that. And also it gives me a second to get some water. So we got about 25 seconds left. In assembler code, it makes a difference if you post or pre-decrement a value depending on its usage. In a for loop, not so much. Most compilers optimize that away these days. So over on the YouTube side, ads are dead, by the way. So over on the YouTube side, just started my transition from that editor, which will not be named, to keep things family friendly, into NeoVim. Nice. I take it you've watched my shorts on that. It's a little overwhelming, but I like it so far. Yeah. Once I switched over to the Vim way of doing things, it's really hard for me to switch away from it, honestly. I don't really like C+ equals. I assume it means C++. Yeah. Especially modern C++. It's very verbose, very complicated, and it tries to do things for you that I think are just frankly not necessary. Like if I wanted to manage language, I would use a managed language. Like C++, stop trying to manage my memory. Just go away with that stuff. Like I don't want it, right? And yeah, all the name spacing stuff and all the super, super long type names for stuff, like it's just, yeah, it's out of control. I do watch both chats, yes. Thanks a lot for your videos. They've helped me learn a lot. Awesome. I'm glad to hear that. Managed to get a 2D sprite render in Vulkan with your explanation. Sweet. That's awesome. If you drop a link in the Discord server over on the Kohi channel, I will take a look at that, because I'm always interested to see what you guys make. I've watched your shorts, but I don't show up a lot, but I have been here since your TypeScript engine days. Man, that was a long time ago. Yeah. That was 2018. So yeah, glad to have you here. Awesome. Thanks for that. Appreciate it. All right. Let me switch over to the Twitch side here for a second. Mavis, thank you so much for the 1 month tier 1 subscription. I appreciate that. Mr. Swez, thank you for the follow. Zach Rocks, thank you for the follow. Not Big, thank you for the follow. I appreciate that. Thank you, guys. You're a huge inspiration. Your video series on YouTube is truly a gem for mankind. Thank you for your efforts. So I appreciate that. That feedback helps a lot. I appreciate that kind of the kind words. So thank you for that. Yeah, the whole purpose in doing it was to hopefully provide the resources that I didn't really have when I was learning how to do this stuff. And the resources that I wish I had. So the fact that you guys find it useful makes it all the more worth it to me to keep doing it. So yeah, I appreciate that. Don't shit on modern C++ now. Well, I mean, I wouldn't say I'm shitting on it, but like, I'm not a fan of it, right? Like I have my preference, and my preference is not modern C++. Stop trying to manage my pointers. Yeah, I mean, that's That's part of the biggest thing, as opposed to and also templates gross. In the context of graphics program, what is a pass? So there's a couple things here. So we have a render graph, which allows us to programmatically set up different events to happen at different times to different render targets. And so we have the concept of a render graph pass that encapsulates a lot of that. And a lot of times that actually encapsulates something called a render pass, which is in Vulkan is actually a structure. And that is used to basically align what frame buffers you're going to be using, which is essentially that aligns like your images that you're going to be drawing to, aligning all your resources that you're going to be drawing to, your rendering pipeline, all that stuff. And it's a way for us to basically say, here's where all the data that we want to draw, here's all the things that we want to do. This is where it's going to go to, right? And so we have a couple of different passes in here. We have our render graph pass, which is a kohi concept, and then we have our render pass, which is a Vulkan concept. And other graphics APIs use render passes as well. But yeah, for us here, it's also Vulkan, right? Hope that makes sense. Pointers are the biggest thing with modern C++, but I liked those self-managed pointers, smart pointers. They take it all away from you. Yeah, I mean, that's the thing. Like if I'm using C or C++, I'm using it because I want control of the memory. My cat is having an allergy attack back here. Poor kitty. So like if I'm using C or C++, it's because I want to control the memory myself. I don't want the language stepping in and doing that for me. If I wanted that, I would use a language that frankly was better at it, right? If I wanted garbage collection and things like that, I would just use a language that did that, but I don't want those things. And so I don't use a language that forces me to do that. And modern C++ kind of has its way of trying to force you to do that and yelling at you when you don't. And I'm not a fan of that, right? So let's see. I think the worst thing in C++ is there's never a right idiomatic way. Yeah, that's 100% true. Do I have a GUI for the engine? So we have a basic GUI that we've started called the standard UI. And so like everything else with this engine, we're developing everything completely from scratch. So we've got a couple of basic controls with that. We've got buttons working, and we have text boxes and editable text boxes, none of which I can show you right now because the engine doesn't compile at the moment. But yeah, we do have a system that we've started building, and we're going to keep adding to it as we need features. But we're only going to add features that we actually need to it, right? We're going to keep it from becoming this huge bloated thing if we can help it. Type deduction in C++ is awful. Yeah. Is it immediate mode or retained? Retained mode. Yeah. We'll probably wind up doing a UI in immediate mode as well. So the way that this engine is architected, everything is done as a plugin. So the renderer is a plugin, the audio system's a plugin. Eventually, when we get around to doing physics, that will be a plugin. And the UI system is also a plugin. So the core engine knows nothing about UI whatsoever. And if you want it, you can use it. And the idea there is that we can have a few different UI systems that are developed separately as plugins. And if you want the features of one, you can add it. If you don't want it, you don't add it, right? And the application will have control over what plugins it uses and doesn't. So you may want all of the full-featured GUI stuff that maybe an editor would need, right? So you may want the standard library for that. But maybe for a game, you don't need all that crap, right? You just need something super lightweight and basic. And so for an editor application that uses the engine, you could include the standard UI versus for your runtime application, it doesn't include that, right? So that's the idea there. The fact that there's a 280-page book dedicated to initialization is all that needs to be said. C++ rant over. 100%. Yep. Can you recommend anything to understand game engine architecture? Yes. The book called Game Engine Architecture. Yes, and this is the one I always recommend. Let me see if I can get it in frame here. So it's Game Engine Architecture by Jason Gregory. highly recommend this book. I can't recommend it enough. The third edition is the most current edition as far as I'm aware. It's not a cheap book, but it covers a lot, and I highly recommend it. Yeah, it's thick, right? It's thick with 2 C's for sure. But yeah, I've read through that book probably 4 or 5 times at this point. It's definitely bulky for sure. Passes and graphics rendering are basically just different steps you go through when rendering a scene, like compute pass, handle physics, main render pass, render all objects, and all sorts of other passes you can imagine. Yeah, like we have a skybox pass, a shadow map pass, a scene pass, a UI pass, right? An editor pass, which is sort of a in between to render our editor gizmo, things like that. So yeah, that's more or less what it is. Cool. All right. So with that, let's continue. So I'm just kind of going through this right now. Okay, so this is the end of the shadow map pass. So let's see. We gather all of this ext terrain geometries. Okay, so this actually is going to have to change a little bit too. Because we want to actually load up all of that stuff into different passes instead of one pass is what I'm thinking. So let's take a look at extended data. So the directional light is something that's used in every pass. However, the terrain geometries and the sort of static geometries, those can actually change between passes. So those should actually be here. So really the only things that we should have here is per cascade data and then the directional light, which I guess I'll move up here. Right? Which is obviously going to break a couple of things down here, but that's not a huge deal. So this is going to be, instead of ext data geometries, this is going to be cascade geometries. And then down here, this is going to be the same thing, cascade, geometry count and geometries, cascade geometry counts, and then cascade geometries. Same thing down here. Let me not code behind my mug there in the camera. All right. So we've got that. And all of these things are allocated using our frame allocator. So we don't have to worry about deallocating that stuff or reaching out to the OS, right? Our custom allocator is handling that for us. So it should be nice and fast. Okay, so we have all that stuff split up. I think that should do it in terms of getting the data into the shape that we need it, so to speak. Let's see, are there any other errors in this file? Yes. So, prepare frame. Pass over, okay, so what is this doing? For each shadow cascade count, directional light views. Oh, is this in the scene pass? This is in the scene pass. Okay, I haven't touched that yet. So that's going to have to actually change as well, I think. Actually, maybe not. I'll have to mess with this in a minute. Let's see. Olwilg, or Olwillig? I'm not sure if I'm pronouncing that correctly. Thank you for the follow, though. I appreciate that. Let's see. How large is the engine currently in lines of code? Too many lines of code, because I don't know how to write short code. That's true. That's true. last time I counted the code, which was a few months ago, it was around 69,000 lines, give or take. So yeah. And a lot of these changes that I've done has actually involved both removing and adding code, so I don't know that that's changed. But yeah, 69K. Yeah, 69. Nice. Coffee Lava, how's it going, man? Good to see you. Okay, so extended pass data, cascade splits, elements. I'm not even 100% sure that that's where this is anymore. Cascade splits. Extended data. That's not going to be right anymore, though. Cascade splits. Isn't that going to be up here? No. Cascade splits elements. EXT data. Did we nuke that? I was looking for it here, and I don't have it up here. Split depth is the only thing I've got. EXT data. Yeah, because this is just this, right? Oh, that's right. It's the scene pass, not the shadow map pass. Okay. Okay, so that actually kind of makes sense. EXT, yeah, okay, it does. This is SP extended data. This is just extended data for the scene extended data. Okay, so this should be cascades sub C split depth. Cloud Meatballs, thank you for the follow. I appreciate that and welcome. Let's see. Balance, yes. Wow, you're working on it solo, right? Yes, I am. So I have, yeah, other people bothering me with issues on GitHub. Yeah, so I am working on it by myself, but I'll pull up the repo real quick. There have been other contributors that have contributed fixes and stuff. The biggest one was Jad Taylor here. He basically did the initial implementation of the Mac OS layer, right? And I was able to take that and mold it into, you know, the standard sort of kohi thing. But he did a lot of work on that. So a big portion of that is thanks to him. But yeah, a lot of folks have been contributing on PRs and stuff here. So there has been some of that. I do have a number of issues I have to comb through. Some of these are more complicated than others. Some of them I could just look at and be like, yeah, that's easy and kill it. But some of them are like marching cubes, CSG style level of creation. Like that's a huge feature, right? So some of these are enhancements. Some of them are bugs, etc. Some of them are long-standing because they're kind of a pain in the butt, and they're a lot of work. But yeah, that's... So if you guys are wondering where all this stuff is at, by the way, kohiengine.com is the main resource for the engine. So I'll just drop that in both chats. And that is sort of the central hub for this whole project. So it started off as a series on YouTube, like a tutorial series, and kind of morphed into couple of different formats over the years. And then we now do development here live on Twitch and YouTube. And I say over the years because it's almost been in development for almost 3 years. And so, you know, it has been just me, right? So that's why it's taking so long. And I do this in my spare time. But yeah, we do have a GitHub repo. I forget how many... 301 commits so far, right? And that's actually not even, I don't even think that counts what's on the PBR branch. This has got 311 commits, and then what I'm actually on right now, 319 commits, right? So it's been quite the project, quite the process for sure. Very inspiring work. I'm finally getting back into some low-level coding after too many years of web dev. I hear that. Struggling to choose a language. So many entries in the space these days. Zig, Odin, Hair, C, etc. So I would say, are there any of them that you're more familiar with than others? Any of them that you've dabbled with before? Because I would say, if so, start with that one. Otherwise, I would recommend C. But I would definitely also say, explore the other ones and see what you like and don't like about them. Okay, so we have that sorted out. Is there anything else in here? Yes. Okay, so if the scene is not loaded, okay, so we don't need this loop anymore. We can just say don't do that scene or that pass. Render graph PFNs, right. So we don't need this in a loop anymore. This is just for pointer functions, right? So we don't need any of that. We just need the singular version of that. And I think that's all the errors out of testbed main. So with that, I think we can now finally actually shift back to the shadow map pass and actually kind of start thinking about how we want to split this stuff up. So what we have is we have our depth textures, our color textures. And these are essentially one texture per frame, right? So if we're triple buffering, that's 3. If we're double buffering, it's 2. And so what I'm thinking is we need to actually split these up, because I could just use offsets into these arrays, right? And just do it that way, but that seems kind of crappy. Instance updates per frame. So we're going to have to do that per cascade as well. Default color map, I think we can just... Actually, we might be able to just use this stuff. Actually, I think we might be able to get away with not having this stuff per cascade. So these need to be per cascade. The camera viewport could be global. That should be fine because that's only the rectangle that we're using, which should be fine. So shaders, locations, texture maps. Okay, I think all of this stuff also should be fine, because we're going to be using the same shader repeatedly for all of these passes. So I guess really the only thing that we need to split out is these two guys, I'm thinking. Let's see. Never go for the language a single job offer wants to know. Instead of learn 3 to 5 languages and then go out there and go out. Yeah, that's good. That's good advice. Even if you just know 2 to 3 languages, that's still fine. Agree with that. You'll pick up more as your career progresses, right? The less, the better. Yeah, there is such a thing as learning too many languages, right? And then you're constantly screwing up syntax between the two. Like I use C++, or I use C++ in my spare time, but at work I use TypeScript. And I can't tell you how many times I've went to go like in TypeScript use the arrow pointer, right? Which doesn't work so well in TypeScript, right? So I would say, you know, get really good at one language and then branch out and use your skills there to learn others. Okay, so let's create a new, we'll call this Cascade, and we kind of hinted at this in a previous stream, but I kind of wound up getting ahead of myself and hadn't done some of the other stuff that we needed to support this. So we're going to have something called Cascade Resources. Olwig, thank you so much for the gift sub. I appreciate that. Thank you. That is very much appreciated. So in cascade resources, this is going to be per cascade resources. So we're going to move these guys here. And eventually we probably need to get rid of this too, but one problem at a time. Let's see. I think everything else can remain there. So what I'm going to do is do cascade resources, and I'll call this cascades. And we'll do max cascade count on that. And again, we might make this more flexible later, but per cascade resources. Okay. All right, so when we create the pass, let's see, is there anything we need to do here? I don't think there is. I think this is just... Shouldn't be anything we need to change there. It's the initialize that's mostly going to be it. So this is where all of our texture creation stuff is going to be at. So we basically just need to loop this here. So you guys are getting ready to see me use C++ again. So U32C equals 0, C is less than max cascade count, C++. There we go. I've used C++. I know. I've done it, chat. I've used C++ on the stream, even though I said I would never do that. But there it is. I've used C++. What am I going to do? That should be 4, not if. Disgusting unfollowed reported channel. Respect for using C++. Awesome. Yeah, if to 4. Yep, I typed the wrong thing there. I was so focused on typing this that I typed the wrong thing. I screw up code all the time on stream. I think it's partially just like as I'm talking, my brain just kind of goes off in different directions and does the wrong thing. So let's do cascade resources, cascade equals internal data cascades sub C. And we want the address of that. All right, and then I can just say cascade depth textures, cascade color textures, and then this is going to be the same thing here and here. And that should get us all of the resource creation that we need. I suppose we probably ought to edit these names though. So we're showing the resolution, the index, but we probably also need the cascade, right? So we'll say cascade. Let's actually modify this a little bit, right? So we'll say resolution and then IDX, right? Let's make the name super descriptive. And the reason I'm bothering with this, as far as the name is concerned, is because when I look at this in RenderDoc, I then can look at that texture and know exactly what it's for, and know exactly where it fits in. So it's not an accident that I'm naming it like that, right? So do this and then change this to depth. All right. And then the last thing is going to be the cascade, which is going to be C. All right. Let's see. In C++, that was valid. It probably is valid in C++, honestly. You actually typed that C++ thing in the loop to mock me. Yeah. No, I'm mocking C++ in general, because that's the only time you'll ever see me use C++ on this stream is right there. Just like that. Let's see. No pair over on the YouTube side. Love your stuff. Thank you. Appreciate that. Appreciate you being here. Okay, so we've got that. Set up the render pass. This should be fine. Attachments. This is just the attachment configuration, not necessarily the actual attachment itself. And we have ads. So for those of you who are new to the stream here over on Twitch or YouTube side, whenever we get ads, I like to pause the stream. So generally speaking, we get ads once every 30 minutes for 90 seconds or up to 90 seconds. Depending on the region and locale where you're at, you may get served only 30 seconds of ads or maybe no ads at all. But I like to make sure that nobody is left out. So I just take a minute, pause the stream while ads are running, and that gives me a chance to hydrate as well. So we've got about 45 seconds, and then we'll get back to it. All right. Just about done with ads. We got about 10 seconds left. All right, and ads are dead. We are back. So thank you guys for bearing with me through the ad break there. And let's just see. Go to the bathroom too before you have to do it during the coding. Yeah, no, I'm good. I actually went right beforehand, so I should be good for a bit. Can't even make jokes when on ad breaks. I mean, I can. I feel you, ad man. Yeah, nice. All right, so we have our resources should be stood up correctly. So I think one other thing that I can think of that we're going to need to change immediately is this shadow map pass attachment texture get. In this, we may actually need to modify a little bit. So this is something that the render graph looks at and says, hey, give me an attachment of this type for this frame number. The problem with that is it doesn't take into account our new array situation where we have multiple cascades. So we need to be a little bit more descriptive in what we actually allow here, or what we're actually asking for. And so we actually may need to modify that a bit, right? Because we had a flat array of color and depth textures before, but now we don't, and we need a way to actually determine that. So let's take a look at the render graph, rather. And so if we have attachment texture get, there's a few places, you know what? So it looks like there's 7 places that look at this. Okay. So the source origin, maybe we ought to... I wonder if we should just pass the source or the sink. And that should know what to get by that. So basically, for anything that is in the render graph that Its source origin is self, basically saying I want this render graph pass to be responsible for providing the source material, right, which is usually a texture. That's the only time that this attachment texture get function pointer is actually implemented. And right now, this is actually the only pass that we have where this is actually implemented. So if we're going to change it, now's the time to change it. So what I'm thinking is maybe instead of the type and a frame count, or a frame index rather, maybe we pass the source and populate it within this instead of doing it here. Because, let's see, this one's setting source textures. This one is also setting source textures. And this one's actually setting an attachment texture. So it's not 100% the same always. So attachment texture. How do we be descriptive about that? Because it's not just sources. It could be sources or attachments. The question is, do I have one function that takes both types and handles that for both, or do I have two different functions, one for each type? I'm thinking two different functions, maybe one for each type makes more sense. Even my knuckles hurt when you did that. Oh, the knuckle snapping. Yeah, that's it's kind of a bad habit, I guess, but it is what it is, right? Let's see. How many systems from the original architecture diagram have been completed or are in development? That's a good question. I would have to look at the original diagram, which I actually don't have. I don't have that image anymore, unfortunately, because the hard drive it was on died, and I didn't have a backup of that one. But I would say a good portion of them are implemented for sure. Like rendering, you could say, is implemented, right? We're adding features to it, but it's implemented. A lot of the file system is loosely implemented. I still have a lot of work I want to do there. Multi-threading is implemented. I'm just trying to remember what all was in that initial. We should probably actually do a look at that at some point, right? If I go to this to-do file that I have in here, this actually lists out all of the stuff that we have to do with X's and the ones that we've done, right? So there's quite a lot there, but we've done quite a lot as well. So I would say this is, in terms of feature completion, 50% maybe. But in terms of being able to actually build a game with it now, albeit a simple game, probably 85 to 90%. So yeah, that's probably where we're at right about now. Quite a long ways, yeah. If you compile right now, does it compile at all, or are there just a few bugs to be fixed? So it's not going to compile right now, no. Because of this right here. So I've got to rethink this this little bit of architecture right here. Because my original thoughts behind this weren't quite descriptive enough. I need a way to basically say what attachment type I need, and then the frame number I need, but also potentially other information. Like in this case, I need to know a cascade index, which nothing else is going to be aware of a cascade index. So that makes me think, okay, well, maybe I should be passing the source that it's going to be hooking up to. And then I can read into the source and say, hey, what is this source? What's the source called? And then based on that, I'll know what to populate with. And then also I could pass the attachment, which is more or less what I'm thinking of doing. So let me actually... Let's implement that real quick, just here in the C file, so we can actually kind of get the implementation where we need it, and then we can go ahead and modify the interface. So shadow map pass. Let's change this to source populate textures. Resources? Nah, we'll just say source populate. So struct render graph pass self. And then we'll say render graph source. Right. I think that's the only thing I'm going to need. Because theoretically I wouldn't even need the frame number because I could just loop through that in here. Okay, so let's see. So we have source name. We can take a look at that. So we can say if the source, and this is going to be the render graph asking the shadow map pass about its own sources. So strings equal, say Vim, why did you fail me? Okay, that's fine. So strings equal I, source name, and then what were some of the things that we set up here? I think oh, I need configure render graph. That's what I needed. So our sources for our render graph, these are the guys that we're basically concerned with, right? So basically the render graph is going to ask us about these sources here and how to populate them. So all I have to do here is basically just use those same names, right? Which I'm just going to hard code this stuff for now. And eventually what I'll do is I'll get rid of these magic strings and use defines instead, right? So if those two things are equal, then, you know, for u32 I equals 0, I is less than 3 or whatever it is, plus I. We'll clean that up in a second. And then we'll say source. I did call that source, right? Yeah, render graph source. Textures. Did my IntelliSense die? I think it did. Equals self internal data, which I don't actually have the, let me get the casted type for that. Just grab this, so I don't have to retype all that. Let's go here. So I'll say internal data cascades. Ooh, that's a good point, actually. Because each of these color buffer... Oh, wait a minute. Do I even need that as a source? I don't even need that as a source, I don't think. I don't even think I need that. I don't need to expose that to anything else. So I'm not going to do color buffer. I'm going to do depth buffer. 0. So I'll do cascades sub 0 depth textures sub I. Right. Okay, so the way that this is going to work is the render graph is basically going to say, hey, pass, for this source, I need you to populate the textures. I'm going to say if that source is called depth buffer 0, then I'm going to take out of the cascades depth textures sub I per frame. And that should be, I think I might need the address of this here. Yep. And that should be what we need, which means that this doesn't really need to be a texture return. We can maybe do a B8. And turn true. And then right, just do this a couple more times. And then if we get down here, return false because nothing was found. Right, so we do, and yes, I could get fancy with a loop with this, but I don't really care. I'm brute forcing it for now, I can clean it up later. Right, so this will be cascades 3, cascades 2, cascades 1. So one thing that you guys will learn as you watch me program is I don't worry necessarily about how clean the code is when I'm first writing it. I get it to work, and then I optimize it, and then I clean it up, right? Because if you spend all your time trying to architect some grand thing, you're going to spend all your time doing that and not actually write features, right? Is there a switch thing in C, not for strings? No. Nope. Write your own game using kohi, and then it'll be even more hyped. Yep, exactly. So hyped for the first game. Do you have any particular genre in mind that the engine will be suited for? Yes, I am going to write... it's going to be kind of an arcade-style game that we're going to write with it. But that's all I want to say for right now, because I'm still developing the idea. But yeah, I do have something in mind. Don't forget to put a to-do there. Yeah, probably what I'll do is move this loop down here and keep an index or something and just, do it there. But I'm not really worried about it, right? This is only ever called when we're standing up the render pass. So I'm not too worried about it. Thinking of learning Direct 3D 9 or maybe even 11 to develop my own game engine. Hopefully it can extend it to use Direct 3D 12 or Vulkan if I become comfortable with those concepts. I would advise against using Direct 3D 9. It's too old at this point. I would definitely say if you're gung-ho on using DirectX, start with at least 11. 12 is a big step because 12 is much closer to how Vulkan is. But yeah, I would say I wouldn't do 9 at this point. I would do 11 if you're going to do Direct 3D. Let's see. Isn't the shadow cascade index actually just an index into the map images? No, not currently. No, they're separate images. So we're not using bitmaps for this. We're actually using separate depth textures because they're all separate passes, right? Because they're in different levels of detail, right? So it's not quite a bitmap that you would use for that. Although I suppose I could. But for the cascades, no, they're actually separate textures at the moment. Which obviously we're gonna make that, we're gonna rework that to be able to do it in a single pass. And I've got some ideas that I want to play with on how we're going to do that. But for right now, I'm just trying to get it to work with all of the other changes that we've made. And then once we get to that point and can nail that down, then we'll focus on a pass for performance. Lobster Chung. I love the name, by the way. Thank you for the follow. I appreciate that. All right. I will, for Ivoca, I will put a to-do here. Clean this up. Dang it. Okay. So that's to populate a source. What was the other thing that I needed? Attachment textures. Attachment texture get. Render target attachments. Okay, so, oh, right. Okay, so this is something a little bit different. So this is for whatever we regenerate render targets. So we would regenerate the render targets for passes that require us to get new images on like a resize, for example. So whenever you resize the window, for example, our scene render pass is going to need new images to work with. Which just so happen to be the swap chain images, but we might have other passes that maybe use their own images that need to be resized as well. So this is what that hooks into. And I'm thinking it ought to have its own entry point as well. Which probably could look something like what we have here existing. Let me think about how I want that to work. So if we're regenerating... our render targets, our pass technically has access to those. So maybe we should just offload that onto the pass and not even bother with this. In fact, we already have that here. Attachment textures regenerate. So maybe we just remove this point and have the regenerate actually handle it. We don't actually have a pass that utilizes that, so I don't really have a way to sort of test that and put it through the grinder, as it were. So I think we're going to get rid of this for now, because that's sort of an outlier exception case that I think could be handled by this point. Yeah, I think that's the way I'm going to do it. All right, so let's see. What we also need to do is, instead of frame number here, we actually need to, we shouldn't be hard coding that to 3, right? So let's do renderer window attachment count get, I think is what that is. U32 frame count. Did I get that right? I did. And so actually this should be frame count instead of 3. There, that's a lot better. All right, so let's steal this error message. And let's do shadow map pass source populates could not populate source, and we'll write the name here. as it is unrecognized. And then instead of attachment type, we just do source name. Oops. And then return false. Okay. I'm pretty happy with that. We should also check if not self or not source. Return false. And now I think we can actually get rid of this guy. All right. And, oh, it looks like we missed a couple things here as well. Oh yeah, in the execution phase, we haven't actually gone through this code yet, so I'm gonna have to change that as well. But let's finish what we were working on first. So I guess we're going to call this source populate at the interface level. However, I'm going to save my session and quit Vim for a second because for some reason my IntelliSense has just completely like pooped itself and stopped working. So, all right. So we have this. So I'm going to take that and go to attachment texture get. Let's peak definition on that. Let's paste this here. Oops. New line, then paste. This is going to be B8. And we're going to call this just source populate. And we're going to get rid of attachment texture get. Right, so that's just that sort of interface function pointer definition for source populate. Source populate equals source populates. And it's bleating about that because we haven't forward declared it. It should be... I thought it'd be somewhere up here. Apparently not. I thought I had that forward declared somewhere. Oh, maybe it's in the header file. It is. So make sure that gets exported. Now it should be available. Okay, what was that? What was that bleating about? Render graph source. Does that really not know what that is? Rude. Don't want to add an include there, so I'll just do that. Okay. Now that should be all good to go. I don't use hard-coded values anymore. I do when I'm standing stuff up, but I try to get rid of them all, right? Let's see. What is the purpose of if not self-checks? Shouldn't it be an assert? I suppose it could be an assert, but the thing I want to avoid is at some point I want to avoid crashing the engine, which is generally what you do for an assert, right? And so I don't generally use asserts except for like serious hard fault stuff because I want to keep from crashing the engine. I'd much rather, use some sort of data that's obviously wrong instead of crashing wherever I can. So I try not to assert in situations like that, because eventually this is going to be user configurable. And if we get a negative result for it, we should probably report on that so that the user actually has some way to fix it. And I'm hoping to be able to do this in a runtime stable way, so that when the user is trying to configure a render pass or a render graph pass, they can actually kind of keep iterating on that and not actually crash the engine, is my thought behind that. What is the terminal you're using? I'm using a WesTerm. So that is... I will drop a link in chat to what that is. I'll drop a link in chat on both sides, actually. We have ads, anyway. So for those of you who are new here, I'd like to just take a quick second and pause the stream whenever ads come up on the Twitch side, and that's simply because I don't want anybody to miss out on content as ads are playing. So once every 30 minutes for 90 seconds we get ad breaks, and we're already almost all the way through that now. But I'd like to go ahead and just pause that, right? Because nothing is worse than having code on the screen and you can't hear what the heck is going on, and you can't even really see it if you're on Twitch, right? So I know the YouTube side doesn't get that, but you know, I ask you guys to just bear with us, and we'll be back. We got about 10 seconds left on the ad break, right? All right, and ads are dead, and we are back. So, question was, what is the terminal I'm using? It is WesTerm. I really like this one. It's very fast. It's cross-platform, so I use it on Windows, Mac, and Linux. It's a nice-looking terminal. It feels good, and it's very fast. So I dropped a link on both chats to that, right? So that is the terminal that I'm using. All right. So, why did you introduce the certs? If you don't want to use them, because I do use them in certain lower level code, right? So there are places that I do use them. It's just I try not to use them in the higher level stuff, right? I use them in low level stuff. So like low level like memory allocation type of stuff, right? And I don't use them as much as I should in some places, especially around the allocator. There's a few places I should be using those, but particularly the Vulkan allocator is probably one of those, actually. But yeah, where were we? Right, I was adding this guy. So we have that hooked up. So instead of attachment target get, this is going to be source populate. Yeah, let me just move this over a little bit. And so for source populate, we're going to use the pass, and then we're going to do source, remove this. We don't actually we don't need this loop anymore, and so we're not going to be setting any of this either. And we'll say if this fails, then we can bleat around about it, right? So failed to populate source name. Source name. Right. I saw a whole bunch of code move. Did I nuke A brace that I shouldn't have nuked. I feel like I did. I definitely did. Or no, I have an extra one maybe. Yeah. Okay. So I'm thinking this should probably also be the responsibility of that function instead of the responsibility here. So let's do... Let's do that. Right. And we should probably also say if not source textures. Because if we already have that array, that's kind of dumb to reallocate it, right? Or should maybe we free it? I guess it doesn't really matter in this case. If that frame count ever changes, though, it could matter. And the frame count could change, because we've seen that. So maybe we do if source textures. Shoot, how am I going to know how big it was before, though? I won't know that without the frame count from before. I'm not going to worry about it right now. It's probably going to bite us in the future. But I'm not going to worry about it. I've got some ideas of how to deal with that, actually. Okay, so we create those if we need to. So we can get rid of this. And we don't need this anymore. Okay. So that's all we should need for that. So actually, I think I can literally just copy this and go to the next place that it's a problem. It's not going to be quite a copy pasta, is it? Texture type, frame count, textures allocate. Actually, I think it is. Okay, so let's paste this here. And then we can actually get rid of... This is all doing the same stuff except that else. So we'll get rid of that. And we'll bleat about it. Which I wonder if we should actually do that in the other spot that we had this to. Because if it's configured to source origin self, then it does not have source populate defined. We should probably do this in the other spot too. Source populate. Okay. So if the source is self, then it should definitely have this implemented. Otherwise, it should not be doing that. I think that makes sense. Okay. Nuke all the braces. Yeah, I mean, there's lots of people out there that say, you know, oh, don't have so much nested code. But the way that I think about it is, for me at least, that makes it easier to read. And there's literally no difference between that and me saying, you know, and then this. Right? When you compile it, it doesn't matter anyway. Yeah, I mean, yes, this probably could use a little bit of cleanup, but I'm changing it so much that I'm trying to keep these cases separate so that it's easier for me to change. And then once I'm sure that all this stuff is locked down, I'll go back and fix it, right? But like, I'm not going to invest the time in doing that now. Like, that's one of those clean coding things that I disagree with. Is while you're still architecting stuff and still figuring things out and changing code around. Like, don't spend too much time cleaning up code that you're likely going to delete anyway. You know what I mean? Let's see. By the way, there is a way to express that a pointer cannot be null in standard C. Just declare it as type self static 1. Some compilers like Clang detects and raises a warning. I'm going to write that down because I've never tried that before. But I will take that into advisement. So thank you, Tamaz, for that. I'm just going to make a note of that so I can know to come back to it. Because I've never tried that before. So that might actually be super useful. Is this game engine open source? Yes, it is 100% open source. It is 100% free and open source. So real quick, I'll just pull this back up. So if we look at the repo, which is here, I'll drop this in chat in both places. If we take a look here, it's Apache 2.0 license, which basically means that you could use the code however you see fit, for personal or commercial, it doesn't matter. The only thing that I ask is if you use the code that you say you use the code. That's it. There will never be any sort of fees associated with this. There will never be any royalties or any licensing other than that. None of that stuff, right? It's 100% open source. It's 100% free. So hope that clears that up. Diamond, good evening. Welcome. Let's see. During development, I agree, but sooner or later you'll have to get over all this code again for Refactor, and that will be a pain in the brine. Pain in the brine. I like that. Yeah, I mean, I do agree, but I'm not at that point yet, right? Like, the render graph is something we added not too long ago, and we're still very much in the process of changing it. One thing that we're going to have to do specifically is we're going to have auto detection of graph path dependencies. And so I suspect when we go to do that, a lot of this is going to change anyways. So a lot of this is very branchy and very nested stuff for now, because I don't care, because a lot of it's probably going to go away, right? We have it working now, but like once we get the dependencies sorted out, then we'll actually be building up a dependency graph, and we'll use that to navigate it, and that'll be a much cleaner implementation. So, in this case, it's very branchy right now, but that's because I know I'm going to refactor it. Okay. So we have that. Trying to think of what else we might need to do other than the actual execute of this. I think we're getting there. Of course, I've probably completely forgotten something that is eventually going to be a problem, but so let's see. So in the shadow map execute, there's not a whole lot of stuff that we actually have to do in here. This is mostly just going through the individual drawing of all the objects. So begin the render pass, use the shader, bind the globals. So this is something that I set up. This was an example of something I wanted to show you guys anyways that I implemented. We now have these arrayed versions of these set by location, right? And that allows me to say I have this shader projections location, which is an array of projections, projection matrices. And I can set element I to this value, right? So we have these arrayed ones that allow us to do that. So I set one per cascade. All right, so geometry. So we set the global there. The globals only need to be set once, and that's not even necessarily per cascade. That can actually be done before that. But I think it needs to be done. I want to say it needs to be done in a render pass, but only during the first render pass. Because we're going to be using the same set of descriptors on every render pass after that for our cascades, but the values aren't going to change because we're basically loading them in once. So once we've applied and updated the descriptor, we don't want to try and update that again, right, after we bind it. So this does need to only happen once, but I don't think I can move it outside of here, because I'm pretty sure this has to happen within a render pass. So what I will do is let's do a B8 needs update, and we're going to set this to P, which is our iterator up here, equals 1. Equals 0 rather. So if it's on the first pass, we'll say needs update is true, otherwise it's false. And then we'll say here, if needs update, then we'll do this. And then here, we'll just pass needs update. So essentially what's going to happen here is on the first iteration of this, we'll bind the globals, which is basically just setting an internal pointer in the shader's memory. Then for each one of the cascades, we'll set the uniform for the view and projection for each one of those. We'll basically fill out those arrays. And then we will apply the global, which is what actually creates the descriptor writes. But we only want to do that in the first frame, so that should only happen when needs update is true. Otherwise, it will bind that descriptor set, but it won't actually perform an update. So that should cover us on that. And then our geometry counts and our terrain geometry counts, those are still going to need to be drawn every time. So instead of ext data, this is going to be cascade, which do we actually have? Let's grab a pointer to a cascade. So we'll say cascade resources cascade equals internal data cascades sub p. We need the address of that. And then down here, instead of ext data, we use cascade. I thought that had our geometry count, does it not? Oh, I don't think we actually solved that yet. I don't think we actually solved that yet, because this is only for texture resources. That's actually not what I want. Does our extended data our extended data is what I want to be looking at. So this actually needs to go to ext data cascades, and this is going to be shadow map cascade data. There we go. That's what I wanted. So cascade. Okay. Just change this to cascade all the way down, essentially. I think, let's see. That one. That one. That one. Okay. I I think that is probably all we need to do. There is one more thing on globals that we have here. So we have to do our if needs update, which we still have from above. So we can do that, and then needs update. So for reference, this is the terrain shadow map shader, and this is the regular shadow map shader up here. They're slightly different because the data sets in the vertex data is different. Did I miss anything? Yes, the destroy. Okay. So for U32, we're going to use C++ again. C equals 0. C is less than max cascade count C++. So we'll do that, and then this is going to be cascade resources. Cascade equals internal data cascades sub C. And we need the address of that. And then I can say cascade color textures and cascade depth textures. And then these two guys can be moved up here. Cool. I think that might actually be it. Let's build and find out. I hate how you hard-coded that stuff that could be true or false, but again, it's to be more clear, because I might change it, right? I don't think I will, but again, I'm not looking for cleanliness of code here. I'm looking for, does it work? And then I'll go back and clean it up, right? Because just doing things like casting indices to a Boolean, right, isn't always the clearest when somebody else reads your code, right? It might be clear to you and I, but if somebody's coming in here to learn a language or learn C++ or something like that, they might not immediately think about something like that. It's not necessarily going to always necessarily make immediate sense to them, right? So I try to be a little bit more explicit, even if it's not necessarily the cleanest solution. Attachment texture get. Oh, that's in testbed main. Okay. So this should be, instead of source populate. I was trying to think of the name. Shadow map source populate. And I can just delete that. All right. Hopefully I saved that before I started building. I can't remember if I did. Yeah, it looks like I did. Okay, cool. All right, so it built. So that's good. I can almost guarantee this is not going to run, though. Or maybe it will, but I'm probably going to get errors because I know that there's stuff I haven't handled yet. So let's run this. Old breakpoints. In fact, let's actually just go through and kill all these. And continue. All right, yeah, I'm not surprised. So let's see, what errors did we get? Shadow map vert, line 20. What did I do there? Oh. I typed U32 as if I have my type defs, right? Is it unsigned int or uint in GLSL? I can't remember now. I guess we'll find out. I struggle with that a little bit sometimes. Unsigned reverse. Okay, it's got to be uint then. That's part of the problem with changing languages all the time that I was talking about before. Cool. Let's see. What else have we got? Instance UBO undeclared identifier. Indeed, that is undeclared. Because it should be global. All right. And these were some changes I made offline as well. So we have these arrayed types up here, right? The projections and the views. And so we access those by cascade index, which I don't think we're actually setting yet. I'm not 100% sure. And so we should be able to index into those. That should theoretically work. If I can get all my shader logic correct. This is the first time I'm actually trying to run this, so you guys are kind of seeing this along with me. Global undeclared identifier. Did I? Oh. Might help to actually type the correct thing. All right, let's try that again. Okay, now we got some different stuff. We still have some GLSL errors in one of the other shaders, though. That's likely the same thing, so let's fix that first. That was in the shadow map terrain shader, the vertex shader, this guy. Wait. Shadow map terrain vert. Oh, I'm in the wrong one. Let's see. Oh, we don't need this anymore. We're not using that. Okay, we have this. Yeah, this is just a uint. Cascade index. And this is going to be also wrong. Global UBO. Global UBO. All right. So obviously we're just going to have to go through and fix these one error at a time, right? We both, you'll never clean it up unless I stumble it over it again in 2 to 3 years. Yeah, I mean, yes, but this is also very much still under construction, right? So like when I go to do a release on this, I'm going to do a cleanup pass over the whole engine. The reason I've avoided doing that so far is because I know it's going to be a massive pull request, right? So, Satrack75, hello, first time I'm messaging. Well, welcome. Good to see you. Glad to have you here. How are you? Thank you for your streams. No problem. It's motivated me to renew my C skills after a 20 plus year hiatus. I can't talk tonight. Well, that's awesome to hear. I'm glad for that, and I really appreciate that feedback. So thank you for that, and I'm glad to have you here. Definitely. Let's see. Anyway, consider raising a warning in those if not self branches, or maybe add something like k-warn once to avoid flooding logs with those warnings. That's not a bad idea, actually, the k-warn once thing. That's not a bad idea at all, either. I'm going to write that down. Thank you, Tomas. That is another thing I'm going to write down. Yeah, obviously there's lots to be desired in this code base, right? There's lots I have to clean out. That's just the way it goes. Shadow map terrain vert 31. Redeclared with a size. What? Did I screw up some syntax here or something? This is line 31, so projections, views. So this, Array must be redeclared with a size before being indexed with a variable. Oh. What a dingus. I was missing that. Might help to actually declare the size, right? Who'd have guessed? All right. Let's run this again. Cool. All right. So we are getting hard validation errors, but at least our shaders compile. Let's see. So push constant ranges. I was wondering if this was going to be an issue. Duplicate stage flags found in ranges 0 and 1. Oh, we have ads. So whenever we have ads over on the Twitch side, I like to just kind of pause the stream and wait for those ads to go by, right? That way nobody misses any content. So those of you on the YouTube side, I know you guys don't get ads quite like over on Twitch, but I do like to pause the stream whenever that happens. Grab some water. So it's a 90-second ad break, and we're about 40 seconds into that. Okay. It might be useful to declare the size. Yeah, exactly, right? I just put a define there with nothing on it. That's probably me just getting distracted at stupid crap, right? Cool, we got about 10 seconds left, and then we can continue. All right, ads are dead. We are back. So, we're now getting this validation error. Let's see. VK create pipeline layout. Duplicate stage flags found in ranges 0 and 1. Spec states any two elements of push constant ranges must not include the same stage and stage flags. Then we also have another one here. Pipeline layout shader. So this is for a shadow map shader. This is one of the reasons I do debug names on everything, right? So I can tell which actual freaking pipeline it's complaining about. Create infos. Vertex bit has a push constant buffer block with range 0 to 68, which is outside the pipeline layout range of 0 to 64. Okay, that one makes sense. So that's because we added this guy, right? So this is 64 bytes. This is another 4. So we need to account for that. But I guess we're not accounting for that when we actually set up the pipeline, which is interesting. So I wonder if that's going to be... Let's see, pipeline layouts. So this is where we actually set the uniform. Right, and we can't do this more than one time either, which is what one of those errors is about. So right now when we call a uniform set, we have our different scopes, right? So we have our local scope, and then we have our scope for global and instance. Global and instance go through this logic here. Local goes through this logic here. And the problem with this is this uses VK command push constants, which happens right then and there. But you can only really call that once on the same range, right? So we need to actually have, we either need to have different ranges, one for each variable, right? And potentially one for each arrayed variable so that we can push it in segments. So we either need to have a bunch of different ranges like that, or we need to have a block of memory that we store all this stuff in and do push constants all at once, similar to how we do here. And I'm wondering what the better option is for that, right? Because realistically, we'd like to be able to push constants like at any point in the pipeline and not have to bind them all together. So I'm thinking ranges might be the way to go. Duck and Slippy, first time chat. Hello. Welcome. I love the name, by the way. That's hysterical. Welcome to the stream. I'm going to work all over it again. That's what she said. Yeah, that's hilarious. It's getting late here. I'm not sure for how long I can actually condensate anymore. 3:20 a.m. Oof, that is late. Yeah, I don't blame you, Ivoca. Don't blame you at all. Yeah, I'm thinking multiple push constant ranges are probably going to be the way to go. So this takes in stage flags, offset, and size. So if we just separate the variables into different push constants. Oh wait, this should be doing that though, actually. Except for the array index part, which we're probably going to have to rework. But it did say that we also only had one pipeline layout range. So we're not taking that into account when we create the pipeline, which is probably the real issue here. Okay. Let me look at push constant ranges, right? We can have a max of 32 of them, which is why I have this hard-coded there, because that's all we're guaranteed. Config push constant range count. Okay, so we're setting that up in the config, and then we do offset and size within that. So our config is probably what we need to look at. So that is going to be in the back end. So let's do create pipeline. So let's see, where are we actually doing? It's been a while since I've looked at this logic, actually. Okay, here is our push constant ranges. Wait, this is what I was just looking at. I need push constant ranges. Here we go. So push constant ranges equals S push constant ranges. S being the shader is that. So we just have a range object there. Range count, that's all configured in the actual shader. So when we're loading up the shader, maybe that's when we do that. So let's do push constant ranges in the shader system. That's probably what we're going to need to look at, but let me see. Create. Okay, so we create the array there. Actually, we just zero it out. The back end, I think, just uses it, whatever it's passed. So I'm thinking we just forgot to update this in here. So R, get aligned range. Okay. So when we add a uniform, if the scope is not local, you know what? I kind of hate the way that that's laid out. I'm going to actually swap this. I'm not really a fan of negatives like that. Right? So if the scope is local, then we get an aligned range for that. I don't think this code is correct. Okay. Let's see. If you had a second renderer plugin, what would you be able to change between them at runtime? Would you be able to change between them at runtime? Right now, currently, no. But it wouldn't take me very much to be able to actually build that in. So all it is just an interface, essentially. So yes, in theory, we could do it. Can my code base do it right now? No. But yeah, theoretically, I could do that. The only problem with that is when you do that, you essentially have to have all of your in-game data maintain its state, while also unloading all of the GPU-specific data, destroying all that stuff for one API, and then reloading all of that other stuff in its current state in the new API. And so doing that can be kind of a pain in the butt, right? Unless of course you just say, well, maybe you have to go to the title screen to do it or something, and then it, relaunches the game or something like that, and just reloads it up for you. There's multiple ways to handle it. Making it a smooth transition from one to the other is probably more effort than it's worth, but I might wind up doing it. We'll see. Maybe it'll be as simple as a hot reload eventually. We'll see. I don't think so, though, because if you have gigs of GPU data loaded, right, you're going to have to reload all of that stuff. So there's time associated with that, and that's where it gets tricky, right? Because you're essentially going to be at a point during that switch where you can't render anything in the application until that new system has got everything loaded and is able to run. So there are things to bear in mind while doing that. So possible, yes. Likely in this engine, I don't know yet. But we'll see. That is why all apps tell you to restart the app after switching from DirectX 9 to 10 or similar. Exactly. Yeah, because it's usually more of a pain in the butt to maintain all of that state and unload all of that stuff from the GPU only, but while maintaining the CPU state. Yeah, it's kind of a pain in the butt. It's more than it's worth, generally speaking. Demigod Cat, thank you for the follow. I appreciate that. Welcome. I think I also missed Skyward Dev's follow 42 minutes ago. I think it might have been during an ad break or something, so thank you for the follow. Committee of One, thank you for the follow. I appreciate that. Appreciate the support there, and welcome. Hope everybody's doing well tonight. So, switching actually can be done at runtime. Yeah, exactly. So we can do it, but there are reasons that we don't. I always explain everything well. I appreciate that. I try my best. Okay, so when we have the local, yeah, we're push constant size. Something about this is not working correctly. Anyone who can explain things with big words gets a follow. It's all about the big words. I appreciate that. All right, so our set index our descriptor set index wouldn't be known here. So we get an aligned range for the new push constant, taking into account the current push constant size, the size of the uniform itself, and then that has to be aligned to a 4-byte offset as required by the Vulkan spec. And I'm pretty sure that's going to be for any other API that uses this kind of thing too. Which reminds me, this concept of push constants probably needs to be moved from the front end to the back end. And we should handle this stuff probably in the Vulkan plugin instead of here. So I'm actually going to do that. Oops. Move the push constant logic to the Vulkan backend and keep this API agnostic. So I think here we're already getting an aligned range, push constant range count, and we increment the size. Entry array length. Oh, I wonder if its array length here is 0 and that's just not increasing the size. I'm willing to bet that's what that is. In fact, we should probably put something in here. Let's do a K-max here. And we'll say either array length or 1, whichever is bigger. That's probably what it is, if I had to guess. Because if that size never moves forward, neither is the offset for push constants. And we never ran into this before because we've only ever had one push constant. So that might have been a bug that's been in here since we initially wrote this. Here are all the big words for you. I'm curious, did you make the website? Yes, I did. Yeah. It's not very fancy, right? But yeah, I did make the website from scratch. It's just all like raw HTML, pretty much. Website was created by a coffee machine AI that went rogue. I'm not an AI. Maybe. You'll never know. Maybe I'm just a really good at AI that's good at concealing the fact that I am, in fact, an AI. We'll never know. Scary Hutman, I just love reading code. Yeah, so do I. Us giant nerds, we love looking at code, right? Reading it, taking it in. Okay, so I'm thinking this hopefully will take care of both errors. We'll see. Maybe not. So let's see. Did we even make any progress at all? Or are we going to have to debug this? We're probably going to have to debug it. Duplicate stage flags found in ranges 0 and 1. Oh, can I not have more than one range? Wait a minute. Could I not have more than one range with the same flags? That's kind of what I'm reading here. That's kind of foobar. Duplicate stage flags found in ranges, but then also this didn't take effect. Pipeline layout range of this. So why is the pipeline getting that layout range is my question. So let's see. And let's look at shader system C. And let's see, what line was that? 523. So I want to see what this does. And this is probably going to have to run through a bunch of different shaders, unfortunately. Let's put a conditional breakpoint here then. And I'm going to say this is greater than 0. Hopefully that catches our case. Yes, it did. Okay, so our shader, just to confirm, is our shadow map shader. Okay. Our push constant ranges. Offset 0 and size 64 for the first one. That's what I expect. All right. Right, so we set that range. Offset 64, size 4. That's also what I expect. Then we up the push constant count, and then we move the push constant size up, which is 68. So this is doing what it's supposed to do. All right, let me kill this. And let's do... I'm trying to think what the next thing I'm going to have to look at is. It's probably going to be... the Vulkan backend. Push constant ranges. So let's put another conditional breakpoint here. And we're going to say this is greater than 1. Which should be this guy here. So we have 2. Our push constant ranges are correct here, as far as this is concerned. So when we go to create the pipeline, I don't need to step through all of this. Let me find the push constants. Here we go. All right. All right, so it does a little checking to make sure that we're not outside the bounds of that, which is fine. So we loop through each range. We set the stage flags. That may wind up being an issue. Okay, so the range, offsets, and size. Should do that twice, right? So ranges. Yeah, those look correct. Okay. So why is it saying it only has 64 for that? That is the confusing part. What else do we have in here? That's really it so far. So pipeline layout. Okay, this is just bleating about the flags. I kind of expect that. But then in the create info... Let's see, is there anything in here that I'm missing? Pipeline layout, maybe. This is all pretty much what I expect it to be, though. All right, so before we create that, let's have a look in here. Stages. I don't think there's anything in here that should be defining that other than... I don't see anything in here. So when I create this, it's probably going to throw a second error. Yeah. P create infos has a push constant buffer block with range 0 to 68, which is outside the pipeline layout range of 0 to 60. Where is it getting that 64? The pipeline layout range of 64. I don't think I have a 64 in here anywhere. Or like, do I have a size of anything in here? Of like mat4? Am I doing that somewhere stupid? Am I doing something that stupid somewhere? No, that's just shader uniform types. Should I search for 64? Uniform size 64. That's just that. Oh, and that's STB image. I don't want that. This is interesting. So where is it getting the 64 from? Put breakpoints all over the place, exactly. Why am I still using hard-coded values for those 32s in there? There must be a define out there somewhere in the Vulkan code base. There might be, there didn't used to be. So the 32s are basically the max guaranteed size for that, which is why I chose that. But yeah, that's probably something I should eliminate as well. But I went with that also because I didn't really want to query the device for that and then have to dynamically create an array when I could just do it on the stack. Because I know per the spec, you're guaranteed. There's a max of 32 of those. Which, if you think about it, is all that you could ever get anyways, because it has to be 4-byte aligned, and the minimum guaranteed amount of a push constant is 128 bytes. So if you take 128 divided by 4, you have 32. So you're never really going to have less than that. And I'm not going to count on support of more than that because 128 is all that's guaranteed by the spec. All right, so I'm trying to look to see if there's anywhere that I've done something stupid. Pipeline layout, create info, range count, push count, ranges. I don't know where it's getting the 64 as part of the problem. And maybe it's only reading the first one because of this first error. It's the only other thing I can think of. So it's not going to let me have multiple ranges with the same stage flags anyway. So I guess why that's the case, I really don't know. I guess that means I'm going to have to implement something that basically shoves this whole thing in there in a single block. Is the only way I can think to get around that, because if it's not going to allow me to have multiple ranges with the same stage flags, Let's see, do I dare open the spec page? We'll see if this actually loads or not. One of the hard-coded 32s caused the problem? No, because they're just... basically what I'm doing with all of those is... So I have this whole block of memory, right, for ranges. Oh, shoot, ads. All right. I'll explain when we get back from ads. So we have a minute and 15 seconds on ads, and then I'll jump back into that explanation. So for you over there on the YouTube side, every 30 minutes on the Twitch side, we get 90 seconds of ads. So just bear with me here for another minute, and we'll jump back into it, right? I just don't want anybody to miss content. Got a little over 30 seconds left. Crisp29, thank you for the hydrate. Appreciate that. Thank you for not showing ads at all. Yeah, not everybody gets them, but some folks do, so I like to pause the stream just to make sure that nobody misses anything. All right, cool. Ads are dead. So, so what I'm doing with this basically is we have this whole array that's created on the stack, right? And what I do is I fill out the ranges that we need and then set this range count. So the way that Vulkan interprets this behind the scenes is it says, okay, well, we have this whole block of memory here, but I only need this much times that amount of memory. And it just reads up to that and stops. So it doesn't actually matter, you know, how many or how big this array is. It's only going to read the first few entries anyway. So hope that makes sense. Starboard Tech, thank you for the follow. Appreciate that. Welcome. All right. Did this actually load? Yes, it loaded, but it did not take me to the bookmark that I wanted. So let's take this validation error and see if we can just search this page for it. There we go. And, oh, maximizing it might have been a mistake. Okay. Let's see. So, if a push constant block is declared in a shader, a push constant range and layout must match both the shader stage and the range. Okay. If resource variables declared in a shader, descriptor slot and layout must match the oh, wait a minute. Wait a minute. Is that saying in our shader that we actually need to... Well, no, there's no way. Unless I need to have this in a different push constant. I should stop changing the size of the window. Okay. The descriptor slot and layout must match the shader stage. Resource variable. This is awkward as hell. If a resource variables is declared in a shader, and the descriptor type is not mutable, Descriptor slot and layout must match. Okay, maybe I'd have to have like this. I wish the spec gave you like examples of what the shader logic should look like. If it's an array, must match descriptor count. It's not an array. Although that might be a problem for us if we do. Okay. I don't think any of this other stuff applies. Okay, so let's take this. So I'm wondering if this means that I need to do... You know what, let me... should it be like push constant, like 0, like kind of like we do the bindings up here is what I'm wondering. I was always under the impression we could push it as one huge block, but maybe not. Maybe it has to be like, oh, I'm not pushing it as a block. Maybe that's the problem. But can you have... I'm wondering if I need to do it like this. That doesn't seem right either, though. I know I'm just tacking a 2 on here, and that's terrible, but we'll have to live with it for a minute. So local UBO 2. I'm not sure if this is what it wants or not. Is it really about push constants? Yeah, I think it is. I think that's the issue, right? Because I don't think... So this was just sent over by Avoca. Thank you for that. Let me just read this real quick. Push constant uniform. Oh, a layout inside of this? That doesn't seem... Because I'm pretty sure that this push constant's what I'm using is correct. I think... Do I really have to declare that? That's super ugly. I guess I could try it. All right, I'll put this back and then do... This would be 0, right? And then this would be 64. I don't know if that's what that page is suggesting, but I suppose we could try it. Let me get my window back here. Let me get rid of these breakpoints. Okay. Let's see what this says now. still bleating about the stage flags thing. Yeah, and it's still saying this. Pipeline layout range of 0.64. And I know, based on this, that our counts are correct. So, like, if I go into here, and look at our pipeline create info, like, I know this is actually being set correctly. In fact, I'll put a breakpoint here after that's been set. So if I do this, oh, wait a minute, that's not the right shader. Let me do a conditional breakpoint here. It's greater than 1. Right, so if we look at this, right, our ranges here are correct. Now, obviously, that's not going to know how to deal with that. So if I take this over here and I do this, and right, those are correct. So I know what is being fed is correct. For some reason, it's getting the range as 0 to 64, and that's it. Which I'm thinking it's because we're using these stage flags, and I'm going to have to like combine these all into a single block of memory. I think that's the only way I'm going to be able to work around it. I don't think there's a way that I'm going to be able to do this otherwise. Because of the fact that they're used in the same shader stages. So this didn't seem to do it, unfortunately. So, as annoying as that is, I just need to think about how I'm going to do this now. So, our typical pattern to this point with our with our uniform assignments has been we sort of bind the scope. So we either bind global or we bind instance, and then we set those uniforms, and then we say, okay, apply that. Either apply global or apply instance. And we actually have some memory reserved to handle that. And basically all that does is move it from the map to memory over to the GPU when we actually apply it via our descriptor writes. So we don't have to go through the descriptor write portion of that for this. But I think what we do need is we need 128 bytes of memory that we can just reuse over and over and over again. We need to bind local, so we need a new point for that. We need to bind the local, set those, which essentially is going to just copy those values to that block of memory. And then when we go ahead and apply local, which is also going to be new, then all we'll do is we'll take that memory and access our push constant logic and push that over to the GPU all at once. So, yeah, that is not something I was intending on, but it is what it is. So we have these push constant ranges, which actually, funny enough, actually I think is going to eliminate this section of code. Because we don't need push constant ranges anymore. Although I suppose we could use those as offsets too, right? But we also have So for our typical uniforms, we have an offset in bytes from the beginning of the uniform, and size. So we already have those things. So we could just treat these as normal uniforms. And the only thing that changes is the way that we copy it to memory in the back end. Instead of using a buffer for that, we essentially just use that block of memory. Which again is a little bit specific to the Vulkan way of doing things. So I'm wondering if we should even abstract that away from the front end altogether and just have uniforms and have the back end handle all of that crap and forget about it on the front end. I'm thinking that's what we should probably do. All right, so let me just review the logic here. So we have, this is all the local stuff. If it's not local, then we check whether or not it's global. And we add it to the global UBO size or the instance UBO size. The index is set according to scope, which makes sense. Okay, so our operation kind of will become a little bit something like this. So I think what I'm thinking I'm going to do is I'm going to set the set index to 2, which doesn't technically exist, but we'll check for that on the back end and use it as a push constant instead. Okay, so let's get rid of push constant ranges out of the shader first. Shouldn't have been there to begin with. And we don't have to worry about this alignment stuff because we're just treating it as a whole block. So we actually don't have to worry about that stuff either. So really all this becomes is a slight change out of this. So, oh, shader push constant size. And push constant stride. We don't need that either. Right? So what we do instead is we just say set index to set to doesn't exist in Vulkan. It's a push constant. All right, so offset. Ooh, that is actually something we need to track separately. Okay, so let's add a third one here. I suppose technically speaking, we could load this into buffer data, right? And just treat it that way. That's kind of pointless though. So we have UBO size, stride, and offset. UBO size, stride, and offset. So we don't need an offset for that. It would really just be U64 local UBO size and U64 64 local UBO stride. And actually we technically don't need that either, but maybe some backends will, so I'll leave it in as well. And then also I'm going to say U64 local UBO offset. We don't need this either, but again, I'm putting it in because there might be a backend that does need it. If we don't have like push constants and DirectX or something like that, then maybe we need to use this. Okay. So we know this isn't global. It's not a sampler. We can't use samplers at the local level. So we'll say the offset is going to be shader local UBO size. Entry size is going to be the config size. Let's see, offset size, set index. I think that's actually all we need. So we can actually delete all this other crap. No longer needed. Much simpler. Okay. All right. So that's adding the uniform. We also need down here. Else if, oh, you know what? Yeah. Entry dot scope. Shader scope local. And we can say shader local UBO size plus equals entry dot size times entry dot array length. Which the funny thing is these all do the same thing, just to different sizes. So I suppose I could clean that up too, but whatever. 4 a.m. here. Good night and happy coding. Well, all right, Ivoka, good to see you. I know that was a few minutes ago, but yeah, thanks for being here. Appreciate it. All right, so UBO size. I think that's all I need to do there. Shader system creates. Okay, so this push constant range count is going to be local UBO offset. We're going to set to 0 for that. We don't need to do this anymore. Okay. I suppose we could also out shader local UBO size equals 0 and local UBO stride equals 0. Okay. Where do we actually set the stride? Push constant stride. So this is probably what we should do is the local UBO stride should be 128. And then we can remove that there. All right. We're not missing anything else on the front end. So I think this is all mostly back-end changes from here out, so. All right, so pipeline config, push constant range count, in our case is always going to be 1, I think. Push constant ranges is, let's see, what kind of object is that? It's just a range. So for this, it's going to be range. Push constant range size is equal to S UBO. Should we just push the whole thing? I think I'm just gonna do the whole thing. Push constant range. The offset is always going to be 0. And then we can take the address of push constant range. One block for the push constant. Okay. So that's that. So in the uniform set, this is where we do something a little bit different. So the uniform set, this really needs to be moved to the uniform apply, right? So where we have this mapped uniform buffer block, I'm going to create another void pointer. And we're going to call this local push constant block. Oops. And this is going to be the block of memory used for push constants. 128 bytes. Right. And what we will do is basically a similar thing as to down here, except to a different block of memory. So this is going to be an internal local push constant block. We're not going to have a bound UBO offset, so that's basically always going to be 0, so that gets negated. Uniform offset plus uniform size times array index. Okay, so that's going to be our target address, and then we'll copy the value and uniform size. Right? And then let's see. We're also going to need to have a actually, this is not going to be static. B8. I'm going to call this apply local just for a second. Local. Just so I can paste this code here. All right. Lagosta, thank you so much for the follow, as well as Brian Cabot. I appreciate the follow. Thank you very much. Hope you all are doing good tonight. All right, context, we need that. Do we have? So we need context. I'm going to grab context and internal. So we're going to need plugin. and the shader. Nanobot ZS7, thank you so much for the follow. I appreciate that, and welcome. Okay. So for push constants, we are going to take pipeline layouts. You're going to take ads. You're going to take an ad break. So for those of you who are new to the channel, we take ad breaks once every 30 minutes for 90 seconds, just to get the Twitch ads out of the way. And we do that. We just kind of pause the stream here just so that nobody misses any of the content as we're sort of working through it, right? So depending on where you are, if you're on YouTube, you might not get ads, sort of the same time as Twitch, but or you may not get ads at all. I'm not 100% sure how it works over on the YouTube side, but on Twitch at least we have those scheduled ad breaks, and so you get a big ad on the screen, you can't actually see what's going on in the stream, so that kind of sucks. And so I like to pause the stream so that nobody misses anything. And depending on where you are, you might get the full 90 seconds of ads. You might get 30 seconds or 15 seconds of ads, and that's it. Or sometimes you'll get like a little banner, and that's it, right? It depends on locale and platform, things like that. So it varies a little bit, but we try to take the lowest common denominator and work with that. So just got a few more seconds here, and then ads will be dead. All right, cool. So ads are dead, and we're back. So thank you for bearing with me there. So our applied local is basically going to push constants, and it's going to take the, let's see, the value. The value is going to be, well, okay, all of this I think is just the size. So I think we can just hard code that to the 128, right? Uniform size. And then the value is going to be, what is it? Is it context? Or is it internal? Local push constant block. That's what we want. What were the arguments for this again? Let me move this up so you guys can see it actually. So let's see, offset. Oh, offset comes before size. Okay, so we don't actually have an offset. So this is 0. Okay. And actually this doesn't return anything, so there's no point in checking to see if that was successful, right? So we'll just call that void. And then we'll say Vulkan renderer apply local. We can get the shader from context bound shader, right? Because that's that. So we don't actually need this. Okay, so all we need is the plugin. So all we basically have to say is apply local. So that'll basically just take all of our push constant block and push it into the push constant at once. And we're always just going to push 128 no matter what we do. And that's going to be kind of the way this works. Which means I'm going to have to hook up a function for this. I'm just trying to think if we need to bind the local scope or not. I think we can handle that on the front end. think we can handle that on the front end. Okay, so let's take this and go to, let's go to the header file, and we'll just paste this guy right down here. All right, and then let's go to the renderer front end. What was that? That was after uniform set. All right, so we'll keep consistent with the function order here. Expose this one. And so for this one, triggers the upload of local uniform data to the GPU. It doesn't have any return, doesn't have any properties, because we don't need the plugin at the front end. So this is just void. And then we can take this and uniform sets. Do the same thing here. Delete that. And apply local, so we'll need the state pointer. And we'll also have to actually create this here. So this is at the interface point. So we'll call this just apply local at that level. We'll need it here. All right, so we'll set up a function pointer for that. Then we'll do state pointer plugin. Apply local plugin. State pointer plugin, rather. Address of state pointer plugin. Oh, right. This one does need the plugin. Struct renderer plugin. All right. So that's the pass through from the front end to the back end. Trying to think if apply instance. Apply globals, bind instance, bind globals. We should probably have bind that somehow. Yeah. So, shader bind globals, bind instance. I don't know if these actually do anything important. This just sets UBO offsets. It doesn't do anything important, but on one of our other renderer APIs it might need to. So what I'm going to do is I'm basically going to define a function here anyways, and it's going to be a no op for this. And we're essentially just not gonna do anything. because we might have to do something in like DirectX. This is intentionally blank and does nothing. Other APIs may need to act here. And that's the case we don't have push constants like on another platform or something, and we have to implement this using an internal buffer or something like that. We can do that. So this can take the same arguments. I'm good with that. Let's do bind instance. And we'll rename this to bind local. Right. And let's see, we have that. So on the front end, we have bind instance and bind globals. So we'll just copy this and copy pasta that. Binds local resources. Samit, thank you so much for the follow. I appreciate that. Let's see. Let me expand this a little bit. TTS Labs, check stream. Okay, let me see. Let me scroll back a little bit here. Did I miss something? Oh my goodness. I switched. Oh boy. Okay. Well, the good thing is all I've been doing is adding a new point. Sorry about that, guys. I kind of got focused and didn't realize what I was doing. I was in the zone, exactly. Wrangling Vulkan, yep. Imagine not finishing your 3D engine in one night. Yeah, 100%. Delete it all and write it again. Yeah, I could. Basically, all I was doing was basically just copying this instance and setting up a bind function for local, which doesn't actually do anything, but the interface point should be there because we're kind of changing the way that it works. So we have the apply local, but we don't need to bind local. It doesn't really do anything. So I'm going to follow that same pattern that I've been following with globals and instance with local. And that's essentially all I'm doing is I'm just putting that into place. So yeah, sorry about the wrong camera there, guys. I'll have to pay more attention to that, I suppose. But yeah, so I will, I guess, let me go to this, and I'll show you guys the other function that I wrote here in just a second. So let me do bind local, and then we have this bind instance. And basically, this is all I've been doing, right? Is just kind of setting up the function points. Let's see. Local. Okay. Local. Yeah, you guys remember that time where I kept coding with the ad screen up? No cutting the beard until kohi is done? My wife might disagree with that. Hard disagree, I'm sure. Especially since this only represents like 4 months, I think. specifically until you get real-time rate, is the same thing we were doing for push constants before, except now it just uses a range of 0 to 128, so it basically passes this whole push constant block every time. Beard trimming stream. I mean, I suppose I could when I go to cut it off, right? All artists and their wives must suffer. I mean, I would argue that they already kind of do. But yeah, I mean, I can't imagine where this would be in a year if I were to not trim it. And actually, I have cut it a little bit. It'd be kind of insane, to be honest. All right, so I have that now. I'm thinking I should probably set up the range. I think that was also in the back end. Push constant range. So the UBO stride is always going to be 128. Yeah, so I should be covered by that. Okay. I'm going to reverse these, though, because I like that order better. All right, so that means when we go to apply or set a local, we're going to have to, like, bind local, set, apply, which means anywhere that we're setting a local, we're going to have to change this, which kind of sucks. But it's a new pattern, and that's the kind of thing that happens when you're developing an engine, right? So let's go to, I guess we'll start with Shadow Pass first, since that's kind of where we've been working tonight. And so where we are, if we execute, let's see, that's going to be down here. Bind instance, apply instance, right? So apply the locals. This is basically going to be... Oh, shoot. I have to pass this. Oh, the shader system doesn't have that either. Shoot. Okay. And there's one other place I have to put this too. Vulkan plugin main is where all the function pointers are hooked up. So I've got to hook those guys up too. So apply, here we go. Out plugin, shader, bind, local equals Vulkan, renderer, shader, bind, local. And then out plugin, shader, apply. Wait a minute, did we not? Did I not add that to the interface? I thought I did. Apply instance, apply globals. Apply local. Oh, it's just called apply local. It should be shader apply local, which does take a shader. Yeah. Shader apply local. Just do a rename on that. Out plugin, shader apply local equals Vulkan renderer shader apply. Oh, I didn't add it to the header file either. Jeez, I'm on a roll tonight. So apply instance. local. Vulkan render apply local. Yeah, it's right there. Why didn't it pick it up? Bind local and apply local. What did I name that? Vulkan render. Oh, that's why. Shader apply local. There we go. Okay. Gotta save the header file for it to be picked up by LSP. Yeah, and you also have to name it the thing that you expect it to be named. But yeah. Vol ren blocking bin lock. Yeah, exactly. Yeah. It uses fuzzy finding for like the LSP resolution. So I've learned that like you can just kind of type the first couple characters of each part of this and it'll find it for you. And it's pretty reliable. So it's made me lazy a little bit in terms of like what I type, but yeah, it's way better than typing out the entire thing, right? So all right. So I think all of that is hooked up. So I should now be able to go to the shader system and hook this bit up. So we have bind instance and apply instance, apply global. I don't think we actually have a bind global in here, funny enough. We don't. So we might want to add that just as an entry point at some point, but let's just do this. Local scoped uniforms operates against the currently used shader. Needs update. We don't actually need that. We're always going to assume that it needs updates. And then this is going to be local. Oops. Okay. So that's it for apply local, and then local scoped uniforms. We don't actually need to have an ID because we're not binding an instance. So we actually don't need this either. So that should be all there is to that. Okay, and then all we need to do here is I think this is just going to be a pass-through, but for the sake of API consistency, return renderer shader bind local. Oh, why do we have an instance ID on that? We don't need that. We do need the bound shader. So to this, oh, this does actually take an instance ID. Shouldn't. Oh boy, copy pasta's hit me hardcore here. That should be shader bind local. That would have been fun to, and I don't think this actually needs the shader. You know what, though? I probably should pass it to the back end anyways, because the back end function might actually need that. I probably should modify this to take in the shader, but not the instance ID. Right, so we have that. Shader bind instance, shader bind local. Does not need an instance ID. Okay. So apply local. Oh, and I did bind local here instead of apply local. I'm apparently really tired tonight. Renderer, shader, apply local. Let me pull up. What was that? I needed apply local. Right, that takes nothing, but probably should take a... Probably should take a shader, right? So let's add that back. No, I'm thinking to match the rest of it. Probably should return a Boolean. And in this case, wait. Why is that Vulkan renderer? That should just be renderer. Renderer, shader, apply local. And then this should take shader S and S. Apply local. Should also return a Boolean and take a shader. Front end shader. Okay, I don't necessarily need to be called front end shader. That should be good enough. Electrosys, thank you for the follow. I appreciate that. All right. This looks cool. I'm learning SDL. I'm hoping to have some time in the future to learn 3D graphics in Vulkan. Awesome. Well, welcome. Jammy20, thank you so much for the follow. Hey, I'm a new viewer. Can you give your introduction? Sure, absolutely. So basically what we're working on this channel is we're building a game engine from scratch using C as the programming language and then Vulkan as our initial rendering backend. So the rendering engine, or the game engine itself, is called Kohi. Let me find, I think I already have. Yep. So the game engine itself is called Kohi. You can find all the information about it on kohiengine.com. So I'll just drop that both in YouTube and Twitch chat. We are simulcasting to both. And so basically this is a series that started off as a tutorial series on YouTube, and kind of morphed over time, tried out different formats to see what works, what didn't work, and ultimately we kind of landed on this live streaming format. And we have ads, which is terrible timing. So I'm going to finish this once I come back from ads. And I'll remember to change the screen this time. I know you guys on YouTube don't really get ads the same as the Twitch side does, but basically the way that it works is every 30 minutes we are served ads on the Twitch side, and I like to pause the stream for that, right? And it's 90 seconds every 30 minutes, so it's not a whole lot of time, but we like to do that so that nobody misses anything that's on the screen, right? So I will continue the introduction as soon as I'm done here. So we've got about a little over 30 seconds left. And yes, I will remember to switch the screen this time. Promise. I actually have my hand over the button. In fact, I could have swore I hit the button last time and it may not have just gone through. I'm not sure. So let's see, we got about 15 seconds left and then I can continue. Okay, ads are dead. So, I'll kind of start over. Yeah, at least if you forget, YouTube sees the same thing. So we're working on the Kohi game engine, which is a game engine that is built from scratch using C as its programming language and Vulkan as its initial backend. And what I mean by that is the engine is designed in a modular format where we can plug different rendering backends into it at some point. Right now, Vulkan is the one that we're focusing on. Eventually, we'll have Direct 3D as well as Metal and maybe even OpenGL. That's a big maybe. And so, like I said, it started as a tutorial series on YouTube and has kind of morphed over time to become this live stream thing that we do here. It is 100% open source and free. So we have a link here to the GitHub, which is here. It is Apache 2.0 license, which means that you can use the engine for whatever you want, free of charge. There will never be any licensing fees. There will never be any royalties. There will never be any of that kind of stuff. It's 100% free. The only thing that you have to do if you use the code is say, hey, I used Kohi, and that's it. It's literally the only requirement. And so it's all available here. All the code that we're working on stream is always available here. We are currently working on the PBR descriptors branch, which is part of the PBR feature branch, which is a big update that we're working on, where we're sort of redoing the rendering pipeline. So the engine itself is designed in a modular type of mindset, such that a lot of major components that you think of when you think of a game engine are actually plugins, meaning that they can be swapped out for different ones. So our rendering is a plugin. Right now we have a Vulkan renderer plugin. We'll eventually have a Direct 3D renderer plugin. And then we'll eventually have a Metal renderer plugin for Mac. So speaking of that, we are cross-platform for the three major desktop platforms. So we have Windows, Mac OS, and Linux support. Linux right now only supports X, so Wayland support's a little bit shaky at the moment, but we are going to be adding that as well. And then in terms of other plugins, so the audio system has a front end that the engine is aware of, but the back end of that is a plugin. So right now that uses OpenAL. If you wanted to use Fmod or something like that, we could build a plugin around that and then use that instead. The physics system eventually will be a plugin. And even our entity component system will be a plugin, right? And so the application that utilizes the engine is what drives what plugins get used and what plugins don't. Another example of a plugin is our standard UI system. So if you don't have a UI or you want to build your own custom UI, you don't have to use the one that comes with this engine. You could just use the one that you build yourself if you wanted to, right? So whereas the editor application would want to use our standard UI that has things like buttons and text boxes and stuff like that, maybe your game runtime does not need to utilize that, and so it could not add that. And so that's basically the premise of the engine. And so everything that we've built here is completely from scratch with a couple of exceptions. So in the core engine at the moment, and this is eventually going to be moved out, we have this vendor folder. where STB image and TrueType are used. And those are header-only libraries by Sean Barrett to load various types of image formats and then fonts. And then the only other library that we use in addition to that is a couple of libraries in our audio plugin, which is here. And that's just for loaders, right? So one for MP3 and one for STB Vorbis for Vorbis file formats. Those are things I just didn't see the value in writing from scratch, right? But other than those things, everything here is completely written from scratch. So that is basically the intro. I hope that helps. Deserve a follow. I appreciate that. Thank you. Okay, so hey, I recently jumped into math because I never learned it properly, so I started dedicating myself to math more than programming. How do you think I should reconsider spending more time on programming or math? I mean, the math stuff is definitely important, especially linear algebra, but as you will see on this stream, I am no math wizard, right? I'm no expert at that. I have to look up stuff on the math side all the time, and that's never really stopped me from doing this. So have an understanding of it. Understand at least the overarching concepts of it and how it works and what to use, when to use a dot product versus cross, things like that. But as far as the actual formulas, I wouldn't bother too much unless you're going to be writing your own math library like we did here. And then even then, once you have it written, you're probably never going to touch it again, right? So I would say spend more time on programming after you understand the basic concepts in math. Completely unrelated question. How does Windows handle audio? Do you have to use Win32 or it's another API? So that was the reason I used OpenAL, is because OpenAL is similar to like OpenGL, how it's cross-platform compatible and abstracts the hardware away. OpenAL is the equivalent of that. And so that's what I used for audio. So it uses the same thing across the board for that. Let's see. Beyond understanding the underlying concepts, writing implementations will be the best path for understanding and retention, in my opinion. Absolutely. Getting your hands dirty and actually getting in there and writing code and then throwing it away and writing it again is the best way that you're going to understand it, right? I've always had the utmost respect for folks who build game engines. I've always looked up to the people that have made these engines starting in the 90s. Yeah, absolutely. Especially when this tech wasn't common and the methods of doing it weren't known, right? Especially the folks writing C, because I know that is best. I'm a C++ guy. It would probably be worthwhile for me to learn C. I would agree with that. I always think that having a solid understanding of C makes you a better C++ programmer, for sure. Okay, so I like to do Android development. Can you give some tips, native or cross-platform? What should I do? Depends on the application, right? Depends on what you're trying to write. And it depends on how deep you want to go, because that's kind of a really, really, really deep rabbit hole if you go native, right? So I haven't written anything targeted on Android since like Android 2. So I don't know that I'm qualified to answer that question these days, but I would say probably they generally recommend you avoid native code unless you have a reason, to go down that route. And a game engine would be a reason, and I do eventually intend to target Android with this. I'm just not there yet. So I can't answer that question now, but after I do research and start implementing it, I could probably answer it then. Having learned C, then C++, it's amazing to me how abstracted C++ has become compared to C. Not a fan personally. I agree with that wholeheartedly. Java or Kotlin, yeah. So the last time I touched Android development, I had to use Java, which also felt gross, which is why I haven't done it again. But that's because I'm a C person, right? So I would say probably, I've never used Kotlin, so I can't say Java or Kotlin, right? Because I haven't used one of them. So I can't really answer that either, unfortunately. I'm not qualified to give an answer on that. I wouldn't think. All right. Call to undeclared function. Render shader apply locals. So renderer shader apply local. Is this called something else in the header file? Oh. Yes, it was. Okay. All right. Let me just build this real quick, because I feel like I flubbed a thing or two when I was fumbling my way through this. Yeah, I thought so. Incompatible function pointer types. Vulkan plugin main. Shader bind local. Vulkan renderer bind. Okay. So we've got some issues around that. It looks like the apply local is also wrong. So Vulkan renderer shader apply local. So this needs to take in the struct shader s, which means this also needs to do shader s. Okay, I guess we're doing it that way. Kotlin because it can't possibly be worse. I mean, there's Java, right? I think C++ is more for huge business applications where abstraction can help in gigantic code bases. C is better for projects that are more specific. Yes and no. I think part of the problem with huge projects like that is over abstraction, right? Which I think C++ kind of bends your will to want to over abstract things. I don't think that's always necessary, though. I think it's perfectly reasonable to write a AAA engine in C if you have the right mindset. It's just everybody wants to do OOP these days. And that's not really compatible all that much with C. I mean, you could do it, but... I am Sahil Sunawane. I hope I pronounced that correctly. Thank you for the follow, by the way. Also, same to Jim A20. Thank you for the follow. All right. Render plugin, shader, unsigned int. Is this still wrong in the interface, maybe? Let's see. So it's bleating about both of these. So this is just plugin shader B8. Okay. This one is plugin shader. Why is it complaining about... What is this one then? Plugin shader. Oh. This needs to be B8. Okay, so that's that one solved. That one is a B8. as is this one. But I have a feeling the header file is wrong. Bind local. Yeah, that still has the instance ID. That's why. Okay. Unused variable. Okay, that's... context. Where is it saying that? 2681. Really? We don't use the context here at all? Okay. I guess that makes sense. Okay. The question is, have we implemented this properly? Actually, I know we haven't, because we were in the middle of this, trying to figure this out. So this should be shader. Oh, did my IntelliSense die again? Shader system. Apply local. This is what we were in the middle of, right? Okay, and then let's see, we need this. And then return renderer shader apply, oops, bind local s. Just make sure that builds. Have you implemented this correctly? Odds in Vegas are no, absolutely. Yeah, I missed something for sure. Say that as somebody who never seems to implement it correctly. Yeah. I'm more surprised when I get something right and it runs the first time than anything, honestly. Shader system bind local. And then shader system apply local. All right, so that is the pattern that we're going to follow for locals. It's a heck of a lot of work to get that in there, but this is basically what we're going to be doing going forward. So we should be able to set these uniforms individually in between these calls. And this one doesn't matter as much as this one in the Vulkan backend, but it might matter in another backend. So I'm just going to say that we should definitely just, out of habit, always bind local and then apply. However, it seems... Oh, my IntelliSense recovered. Cool. We have another section of locals down here. So bind local, shader system apply local. Right? Okay, so that is the shadow map pass. So we have these other passes that we basically need to do this in. So the skybox pass. Nice, we don't even have local here at all. So I'm just gonna have to search for, I guess, model. Do we not even have a local in this one? Skybox. Shader config. Oh, we don't even have a local in that one. Okay, so we can skip that one. Sweet. Let's do, we did shadow map pass. Editor pass, I guess, is next. Okay, that's getting the uniform location. Here's the model matrix. So we need to shader system bind local. Shader system apply local. Let's see. Do UI pass next. Okay, that's getting the locations there. Set by location. This is for the clip mask. I think we do need to set this here. So we'll do system bind local, shader system apply local. And I could have swore there's another, yeah, there's another section here. Shader system bind local, shader system apply local. Okay, that's it for that one. Should be anyway. So that was UI pass we just did. So scene pass is next. Material system apply local. Is really just a pass through. I feel like I should probably modify that. So let's do, because I know there's some stuff that calls this. So we'll say renderer bind local. Or no, I want shader system, not renderer. Shader system bind local. And then shader system apply local. But instead of returning this, be result equals false. Result equals that. Then we do that. And then we say if not result, then we bleat about it, right? And I guess we can really just say return result. So that way we get that there. And I think that should cover everything. Let's see. You know what industry wants, native or cross-platform? I'm confused. I honestly don't know the answer to that. I wish I did. I just want to start my career because web dev has some much rush to it. Although Android development would be nice. Android would be good to start. Do with what you think. Yeah, I mean, yeah, I can't really speak to that, right? Because I haven't done Android targeted development in the industry per se. It's been one of the targets that I've done, but a lot of the stuff that I've targeted on mobile was web based, so that's completely different, right? So I couldn't reliably answer that for you in terms of like having a qualified answer that I'd be comfortable giving. Okay. So we've built. Let's see how much this blows up. Okay. Can't say I'm surprised about that. See, do we get any errors in here first off before I look at anything else? No. Okay, well that's a good sign. Although, yeah, no, all this looks correct. Okay, so what is this bleating about? I can't read. What can't it read? Target attachments. So that's not. Is there something in here that's. It's trying to read a null pointer, but from where? One of these arguments, probably. Attachment count. Attachments. No, that's created. Oh, wait a minute. I think it's going to be this one. Texture is null. Okay. And use custom size is true on this one. Okay, so we're regenerating the render targets. This is for the shadow map pass. I'll bet this has to do with all of that logic that we changed around sources and sinks. So the target here is the render attachment type color. Which doesn't have a texture. I wonder if that's because we removed configure render graph. I wonder if it's because we removed this guy. Which having that enabled is going to cause other issues. Nada. Texture is null. Okay, so this probably is still fallout from that. So oops, that's not what I wanted. Render graph. See. Source populate. Yeah, bad. So we've got another 90-second ad break here. And I will remember to switch it back this time. I think this directly has to do with that code I nuked, by the way. I'm thinking. Got about 20 seconds left on our ad break, and we will continue. All right. Ads are dead. So I'm thinking this is probably directly caused by the logic that we removed here. So I'm thinking maybe I should put that back and try and re-implement that, right? So let's see if I go to this, and I think it was this section here. Yeah. If I revert that change. And attachment texture get. So I basically need to I guess it should be attachment populate. And that would give me what I need here. So graph. So we have source populate. Let's do a B8 attachment populate. Struct render graph pass self, and then what is this type here? Render target attachment. So we go to the bottom of this. All right. And I'll call this shadow map pass attachment populate. And we'll go down to the bottom here. And we'll implement this. And it's basically just going to be like this, right? So attachment type. So I think in this case, I can literally say if attachment type equals attachment type color, then I can make an assumption about the color texture that I want to use. Oh shoot, that's not a flat array anymore though. That was part of the issue before. So if I regenerate this, so I think this is literally going by target attachment count, right? So if let me create this first. Less than attachment. What was it? Target attachment count. Oh, I need the render target itself, don't I? Poop. This isn't even completely correct. This needs to be... This needs to be the render target itself, not the render target attachment. Which means this needs to be render target. So even outside of this, I have to say U32 A equals 0, A is less than target attachment count plus A. Then inside of that is where that if statement goes. The render target attachment is going to be target attachments sub A. And we need the reference or the address of that. Now we can check this. And we kind of have the same problem. Because how do we actually define which set of these we want to use for this? That is a conundrum. Let's see. Let me catch up on chat here because I feel like I'm a little bit behind there. Man, the Android SDK is so painful to get it working. Yeah, that was my experience back in the day too. Been an Android dev for 10 years now. The need for Android devs is still pretty high, and the vast majority of companies are now using Kotlin. Okay, that's interesting to use. That's what he was asking. Yeah, it was somebody over on the YouTube side. So yeah. Olaweg, good night. So I'm curious, do you use IMGUI for the editor? Nope. We are rolling our own UI system for that as well. We don't actually have the editor up and running yet. We have parts and pieces of it that we kind of have in our testbed application that we're going to use to build the editor. But yeah, we don't have that yet. But we are building the UI for that from scratch as well. So all the text boxes and buttons and all that stuff, we're building it from scratch. We actually have those things I've listed so far. So, and I could argue that most controls are actually based off of a button or text control, right? We even have editable text boxes. We even have that as well. Which doesn't sound like that big of a deal, but it is a big deal. Okay. So for all attachments and frames. So in this case, yeah, but see, we shouldn't have to do this. Render target attachment source self. I guess the regeneration is not necessarily needed. But hooking this up, I guess, is kind of needed. I don't know whether to just hook it to the first one and forget it, or it feels wrong. Because that's going to use the wrong attachment to try and draw to, right? So theoretically, we need attachments for all that stuff. And that's the part that we don't actually have figured out either, as far as what attachment we use on what pass. So that's going to have to be something we figure out as well. Maybe when we figure that out, we'll figure this out, actually. So that one we're going to have to think about before we can even build that. What I think I might do is fill out this. So we'll say attachment, populate. And then let's actually do pass attachment populate, and we'll do pass attachment incompatible pointer, but why though? Oh, because it should be the target. So this should be... Oh, wait a minute, though. So this loop is already handled here. So I do need the attachment. Shadow map pass header. Attachment. Oops. Right. So attachment populates, and then render graph. If I can spell. Attachment. Okay. Right. So we don't need to do this because that's done internally. So we basically just check to see if that fails. So that implements that part. But this I don't quite know what to do about. And technically speaking, the problem is also going to extend to these, right? Because we also have that. Right? So I could literally just do that. So in this case, we'd return true, return true. Yeah, okay. Let's see. Text is a nightmare. Oh yeah. Do a lot of work with text at my current job, and it blows my mind how complex it can be. Yeah. We've dealt with a lot of those complexities here. Like we generate all of our glyphs on the fly using TrueType fonts. That was interesting to get working. And then all the things like navigating text boxes that you take for granted. You know, scrolling all the way to the right in overflow situations, scrolling all the way to the left. What happens when you hit the home and end keys? What happens if you hit shift home? You know, highlighting, backspacing, typing letters over it, all that stuff. It's still not 100% there, but I'd say it's like 90% there. There's probably still some edge cases I missed, but yeah, it's crazy. Okay, I wanted to ask a serious question regarding building a game from nothing to releasing it in demos and the full product as well. I'm trying to make a game from scratch. So what I'd like to ask, get across, is that how would I go about building a game in a way that allows me to create so that I could release it to the public without a game engine? And build content for it as well. So, I mean, that's kind of what we're more or less doing here. It's definitely going to be an uphill battle, right? Doing it without an engine is not something that's simple, right? There's a lot that you have to build that normally comes with an engine that you'd get otherwise. So basically you'd wind up with a code base, essentially something like this, maybe not as fancy, right? You could have something that's not as generic as what we're doing here. That maybe targets OpenGL or something if you wanted to do that. You probably would want to make use of some pre-existing math functions / a library. You might even want to do something along the lines of handling windowing for you, so like SDL maybe, because SDL is more of a framework than an engine, so you could build on top of that. But yeah, like if you're, put it this way, if you're asking that question, you're probably not ready to roll it 100% on your own yet without having some sort of reference for that, right? Yeah, so you can also use a different language as well. You know, if it's not a particularly complex game, you could use a higher level language. Like I've developed games in small engines using TypeScript / JavaScript as well. That's a thing that you could do. And so that would be maybe somewhere you could start. But yeah, that's kind of a loaded question, so it's kind of hard to answer all in one shot because I don't know exactly, you know, where your skill level is and all that. You use C++ as of recent to learn OpenGL. Okay, so that's good. So yeah, you could definitely build something out of that. I would say probably use SDL for your windowing, unless you really want to tackle that. And then you could use, you know, kohi as an example of how you'd handle a windowing cross-platform. But yeah, it also depends on, you know, what platforms do you want to support. Low-level game dev, yeah. Yeah, he did do it. Yep, I've seen some of his stuff. Yep. Okay. I'm still not convinced that this is going to give me what I want. So okay, maybe I'll explain this graphically as to what the problem is I'm trying to overcome rather. So previously our shadow map pass, right, had two sets of attachments, right? So there was the color attachment and the depth attachment, right? And because we had triple buffering, there were 3 of each of those, right? So, 0, 1, and 2. 0, 1, and 2. And so it was very easy for us to say, okay, we're just going to call this entire pass a bunch of times. So we essentially had a loop that encased this. Now what we have is we have kind of the same thing, but we have this concept of cascades. And each cascade has their own set of these things, right? Right, and so this is a cascade. Sorry about my terrible mouse handwriting here, right? And so we have, in our case, we have 4 sets of this, right? And so we don't have a clean mapping of attachments to render pass like we did here, because we were just calling this multiple times and we're saying execute this thing, and it would always say, okay, well, what frame am I on, 0, 1, or 2, and then just do that, right? And the problem with this is we have to say, okay, we want to execute this thing, but we want to, within this, execute this one, then this one, then this one, then this one. But externally, as far as the render graph is concerned, it only knows that this one thing exists. It doesn't have a concept of multiple passes existing in this. And so I need a way, basically, to map whichever of these we're on currently to say, okay, this is the current set I'm using, or this is the current set I'm using. And then send those back to the outer mapping of color and depth, right? So that's basically what I'm trying to figure out. And I don't think I'm going to figure that out tonight. I think I need to sit on it for a bit and figure it out there, right? But yeah, that's basically what I have to figure out to move on from here. And it's not a hard problem. I think it's just my brain is a little bit tired. I mean, I'm not sure how linked friendly chat is, but I'd love to show my progress on OpenGL. Go ahead and drop a link. That's fine. How did it not work? My auto mod probably. Okay, so what I would do is go on our Discord server. I'll put a link here in chat. Go on the Discord server and drop the link in the Kohi channel, and I'll take a look at it. And anybody that is watching this stream, go ahead and on the Discord server and check out Sleepy Mushroom's link there. And I'm saying you can drop it in there instead of like an advertising channel because we're talking about it on the stream. So ordinarily speaking, you'd probably want to drop that in a better suited category, but go ahead and drop it in the Kohi channel for now. Coffee Lava, long stream today. PogChamp, yep. It is a long stream today, and my brain is starting to feel it. So I think I'm nearing the end of what I can do for today, just because my brain is kind of... I wrote a lot of code today. And it's kind of, it's been kind of complex working around all this descriptor stuff. And I think I'm actually done with that, interestingly enough. Oh, T-Cap, what's going on, man? Good to see you here. You guys beefing in chat. I love it. Oh, that's great. Good to have both of you guys here. Welcome. So, yeah, ironically, I think all the descriptor work that I was doing, I think I'm done with that. I think what's holding me up is this problem now. So, I don't even think there's a way I can hack it to like make it work. I think I just have to fix it the right way. Which is probably what's also going to replace this crap up here, because I'm not happy with that either. Let's see. I'm going to snooze the ads here. Just because we're tying up the stream and I don't want ads to run in the middle of it. So, I think what I'm going to do is I'm going to upload the progress that I have thus far. Let's do a status. Those are all the files we changed on the stream tonight. So, no wonder my brain is a little bit out there. So, oops, git add dot git commit Descriptor refactor complete, I think. Also moved refactored push constant logic. Having to do with uniform setting. Which I actually forgot. I need to update the changelog for that too. Alright, so updated the API around local uniforms to require a bind set use flow apply flow similar to the other scopes. Refactored Vulkan push constant logic to handle the above. All right, that should be good. And I'm just going to cheat and copy the commit message. All right, so at least all of this code will be available for you guys up there if you're interested in it. And then next time we pick this up, that's kind of where we'll pick up. All right, so let me see. Let me see who is on. Let's see. Who can I raid? Let's see. Trying to find somebody I haven't raided before. See you next time. Have a good night, day. Yeah, exactly. It's about to hit midnight for me, actually. Let's see. I'm just looking for something that seems like an interesting channel to raid. Move this down here so you guys can see it. Let's do... You know, this project was really interesting. I think I raided him last week also, but I'm gonna raid New Jank, I think. So that is who I'm going to raid. Because that project looks really cool, and I'm definitely interested to see where he takes it, right? So, all right. With that said, thank you guys so much for being here, and also on the YouTube side as well, I'll drop a Twitch link for you there. Make sure to follow me in all of the places. I would greatly appreciate it. And yeah, I'll catch you guys on the next stream. All right, see ya.